Good morning, good afternoon, and good evening, everybody, and welcome to another episode of Loosely Coupled by Bridging the Gap. My name is Karol Skrzynski, and I'll be your host tonight. And today, for the first time, I think, ever, we actually can welcome our guests and myself with good morning, good afternoon, and, good evening, because the guests today are from completely different time zones. And we're going to be talking about something quite interesting. A little bit of psychology, quite a lot of tech, quite a lot of architecture. The topic today is Kafka cargo cult, but we're not going to be limiting ourselves to Kafka. We're going to be talking about event-driven architecture. That's just the title. So, without further ado, joining me today in the studio, we have Chris Simon coming to us from Sydney, Australia. It's 3 a.m. in Sydney at the moment, and Aaron Lee coming from was it Toronto, Canada?
Toronto. Yep, that's where I am.
Toronto. So what is that? Eastern time?
Eastern time, it is 1 o'clock.
Eastern time, 1 o'clock. So we have quite a difference. So it's 1 o'clock Toronto, 7 p.m. Central European summertime, and then 3 a.m. In Sydney. Well, Chris, thank you for your sacrifice on sleep to join us in studio to talk about
you're very welcome, Karol.
EDA.
As I said, this is one of the small prices to pay to live in such a wonderful place as Sydney, Australia.
There you go.
Aside of spiders, right? No, I don't think you got that many spiders in Sydney per se, but in Australia, spiders are a thing. Quite so.
There's plenty of spiders in Sydney if you want to get to know them, but they're not bad.
Yeah. Anyhow, guys, so short introductions. You've both been guests at this stream already. Chris, it's your third time, Aaron, second time coming to Loosely Coupled. You both are in software development, software architecture. Well, Aaron here specifically works for Solace, so a very known event broker company. Chris, less affiliated with specific technologies. So what's your connection to event-driven architecture, other than, well, in Aaron's case, affiliation with a specific brand, right?
Chris, you want to go first? Take that.
Yeah, sure. So it's interesting. My background is I was a CTO at a startup here in Australia for quite a few years, and being a relatively small business as a CTO, still had a lot of responsibility for architecture and delivery, and so I think my connection to EDA is that I sort of got into it in the process of implementing the systems that business was using. And then it became sort of more of a focus for me after I left that business and moved into independent consulting, which is what I do now. So I'm an independent consultant. I support teams that do training in domain-driven design and then software architecture. And I just kind of found myself frequently coming into organizations that had, adopted maybe a little bit of, what you might call the cargo cult mindset, or the hammer mindset of, once you have a tool, everything looks like a nail. So I found myself sort of trying to find ways to help them understand, like, what's the right tool for the job in this space. And it's interesting because my focus more is actually on, like, what I call the logical view of systems, like the domain modeling and the domain analysis. But eventually, obviously, it needs to become a live operational system. So I'm really interested in that intersection between how do you connect the dots between the decisions that you're making around the technologies you're going to choose and the way you're going to implement them, and why you can justify that based on the logical needs of the domain is what I'm really interested in.
Cool.
Right.
Me? Well, I'm kind of, I guess the opposite, right? I work for a company, Solace, you may have heard of it. I'm not here in an official capacity, by the way. I am just here as a guy who only has Solace shirts in his closet. And I'm quite opinionated in the technology we think customers should choose, unlike Chris, who kind of looks across the spectrum of different things and what tool to use where. I'm a Java developer by trade, started at Solace 15 years ago. I have worked as a professional services consultant there, as a solutions engineer on the sales team, as a developer advocate. So I've done a bunch of different hats in my time here, lived a bunch of different places. Yeah, back in Toronto, back in Canada, where I'm originally from. Ottawa, actually. So speaking of Alanis Morissette, I'm sure we'll get into that at some point. She's from Ottawa, and I have a friend who went to high school with her. So very
cool.
Woo!
Shout out to Dave.
So yeah,
he's listening. But
so the common theme between the three of us is, well, event-driven architecture, so software, but also Alanis Morissette, and that's not exactly shown anywhere in the description of the event, but the original trigger for this live stream today was Chris's talk at DDD Europe, which was titled 10,000 streams when all you need is a queue.
It's great. It's a great title. It's an awesome.
It's a great title, and it was amazing that half of people didn't catch the reference to.
No,
isn't it
where are all the
ironic?
hands?
Yeah.
They're too young. That was a
Too
great
young,
album.
wrong
Great song.
cultural context is my suspicion. I've done this talk in a few places now, London, Copenhagen, Antwerp, and some online sessions. And yeah, definitely London had the highest proportion of people that recognized it, but not everybody. And I think, we are showing our age. There's the hidden privilege of age and experience. It's maybe what we carry there in having the privilege of knowing Alanis Morissette, which I do consider a privilege. Not personally, myself.
I've been listening to Alanis Morissette on tapes back when I was a teenager. So that was an a long time ago, and because of that, because of the talk, I was like, oh god damn it, now I need to listen to Alanis Morissette again. And reading the abstract for your talk, Chris, I was like, god damn it, no, I'm not gonna get that song out of my head. Thank you, ADHD, right? But yeah, so to some degree, Alanis Morissette is a shared factor, and that brings us to talking about streams versus queues versus topics. So basically, we're looking at Kafka cargo cult because that's a very common occurrence. We don't see operational message broker cargo cults at the moment at all. Everybody in the EDA space, well, they are kind of aware of like RabbitMQ, ActiveMQ, TIBCO EMS, and these kind of brokers, and different protocols like the old school JMS or AMQP, MQTT for IoT usages now in terms of Solus SMF, or just using the brokers over HTTP, which is also a possibility with some of the brokers that are available on the market as open source solutions or licensed solutions. And Kafka, in that regards, is something completely different. While it's still called a message broker and it's very heavily marketed by Confluent as a solution for event-driven architecture, my argument is that it is not a great solution for event-driven architecture as per definition of event-driven architecture.
Well, this is, I don't know, are you ready
curious
for people
to hear
chime in
what
here?
you think.
I think, when obviously the title of the talk is it's like 10,000 streams and what we need is a queue, which is a nod to the fact that I think more people are adopting streams when they should be using queues than the other way around. Doesn't mean that they don't think there's a place for streams and streaming technologies. It's just my experience, my observation has been that the bias in the sector has been to lean one way more than the other. But it's interesting you said, according to the definition of event-driven architecture, and this is like, on the topic of psychology and cargo cults, something that I think is really interesting because there's very few topics in the tech sector that have a clear definition that is universally agreed on. So, when you say according to the definition, I would say according to your definition of event.
No, he's pulling out a book. We're gonna
you can appeal. You can appeal to authority in that sense, but I can find another book that defines it a different way.
Probably.
So,
can we define what a cargo cult is for those listening who might not know what cargo cult is specifically?
So we just talked about this before, just for a friend. Before the stream, it's actually one of your colleagues, Aaron, that introduced me to the term, and I didn't know that. So cargo cult comes from the Melanesia, and somewhere around the Second World War, as far as I remember. There were planes flying over the islands and dropping cargo with all sorts of things, and people living there didn't know what planes were. So they started basically cults around the planes and trying to recreate the conditions where those planes arrived and dropped the cargo. So that's the cargo cult, right? They were praying so that the planes come and drop more things. And they were trying to recreate those conditions that were on the island, but that was nowhere to be related to the planes flying over and dropping things. And we have the same psychological effect in IT with many things. Basically, we see it's also called the bandwagon effect, etc. Or like you mentioned earlier, Maslow's hammer, so the golden hammer. So the effect is that we're basically see something working in one company, so we try to recreate the scenario where it would be working for us, or just use the tool without understanding what it was actually used and how it was actually used in that company. Prime example being where Kafka is being used. I think Kafka was created by LinkedIn. To manage the feed on your LinkedIn page, and then was used also by Amazon Prime, Netflix, etc. for streaming services. For a good reason.
I'm gonna push back a little bit, Carol, because I don't think that's entirely true. Even though I'm not a big Kafka supporter, I'm pretty sure Kafka was developed primarily as a web server logging scrape tool to ingest into their big data Hadoop data systems for analytics. So they had disparate web servers. I mean, LinkedIn's massive, right? So they got 1 million web servers running all their apps. They were funneling all of that traffic, click, views, all that stuff into Hadoop, and Kafka was the pipeline that was for. And at Netflix, I'm pretty sure it's to orchestrate their backend microservices architecture. I don't think you're not streaming Kafka to your TV. Like that's some kind of weird UDP protocol, I'm sure. No, Kafka is too heavyweight, persistent messaging. You're not going to stream it to a TV. I guarantee you that.
Probably true. I don't really know the architecture.
I think this is another example of terminology,
streams,
right? We use the word stream in different contexts. I mean, some of us are DDD people. We're familiar with the concepts of ubiquitous language in a context, and the word stream in the context of Kafka is different to the word stream in the context of video streaming.
Sure.
So
I think of streams as just a stream of push-based messages, for example. Like stream in Kafka could mean, is it an append-only log? Is that a stream? Because if I'm in Solace World, if I'm just publishing a bunch of messages on a single topic, kind of similar to Kafka, and I'm subscribing to that, that's a stream of data, right? It's like a fire hose or whatever. So terminology. Topics are another thing that gets overloaded a lot, right? So how do you define a topic? I've done a lot of dev workshops and talks. It's like topics are a concept, right? How you implement the topic can be very, very, very different. So
right.
So we interrupted you, Carol. What book were you about to
sorry.
out there to?
I would have
off the rails, sir.
I had like I have so many in this book particularly. I have so many marked places that now it's going to be very hard to actually find where the goddamn definition was, because I've been like highlighting it like crazy. Because for research purposes, I need so many things.
Well, while you look for it,
so basically.
Okay, all right.
So basically, the base definition of event-driven is that something happens in a business, which is constituted an event and an immutable thing, and it's transmitted. A business event, a technical event is very similar in nature, and it's immutable. It happened. It's a fact, and it's transmitted to whoever cares. And then it's transmitted in all sorts of ways. With guaranteed delivery, without guaranteed delivery, depending on the use case, we configure this in very different ways. So we have fire and forget, we have just queuing, we have those broadcasts with persistence in different protocols that was built in completely different ways. All of this was basically possible since the creation of JMS 1.0. So very, very long time ago. And those message brokers, somewhere around the year 2000, mid 2000s, this basically turned from message-oriented middleware somewhere into event-driven architecture. So somebody thought, okay, let's use messaging to actually do events and propagate them. And the first occurrence, to my knowledge, of event-driven that I found in books from that period was event-driven service-oriented architecture. So basically, an ESB where the central point of that ESB is actually a message broker, and a very decentralized ESB. So all the actual APIs were very close to the domain systems that it integrated, and the central focal point was a message broker that facilitated for events and for request reply. That's basically somewhere that evolution. Were there earlier mentions of event-driven architecture per se? To be honest, I don't know. But around before the year 2000, the common term was message-oriented middleware. And this is exactly, for example, what the book Enterprise Integration Patterns by Gregor Hope and Bobby Wolf is about. It's basically about message-oriented middleware and how to design systems and make them communicate in a message-oriented manner.
Enterprise Integration Patterns. It's a great book.
It's a very good book, although misinterpreted as the holy Bible of application integration. But I would argue that it doesn't cover half of the scope of what integration architecture is.
Half.
But it's a great book if you. Yeah, well, it doesn't cover integration brokers and ESBs at all. So that means, well, at least half. But it's a great book if you want to design an event-driven system. Great patterns in there, especially operational patterns that enable you to do a lot of great things aside of moving data in the happy path. So definitely worth reading if you want to learn about event-driven patterns to that sense. But yeah, that's my take on what event-driven architecture is.
So I think I challenged you on that because you said something like, Kafka not a good fit for what the according to the definition of event-driven architecture, and I think there's an interesting lens on that because everything you just described, you can absolutely use Kafka to do that. And I think one of the points I make in the talk that you referenced is that it's not that you can't do it; it's like it's should you do it, and the should becomes in some senses a subjective analysis, but more of an analysis of some of the more nuanced trade-offs around the specifics of how they work. Because I've definitely met people who have built systems that meet all of those criteria of event-driven and use Kafka. And actually, the book I was going to pull out to reference that is called Building Event-Driven Microservices, which is all about using Kafka to build event-driven microservices. And I think actually books like that, and I think there is some affiliation with Confluent there in the authors of that book. Explain why it has such a focus on that. A part of the source of why so many people adopted it. And my point is not that you can't use it; it's should you, and let's look at the nuances in that analysis of comparison to sort of help make that decision. Because I did get some pushback. Some people came to this talk and they're like, "What are you talking about? I've done this and it was fine." And I'm like, was it fine? Was it really fine? And then you talk into how often do you have issues? And but we did this to solve it. I'm like, well, maybe you wouldn't have even had to
workarounds, engineering workarounds and stuff.
Yeah, exactly.
Yeah. So the same situation as we experience with integration platforms. So one of the biggest failures of event-driven architecture, service-oriented architecture back in the day, alongside not accounting for organizational maturity and governance, was the fact that people just pushed a lot of business logic into integration platforms, and basically they were not supposed to do that, and they created very tight coupling within the integration platform to their business processes, where integration platforms were supposed to serve only as pipes moving data in a somewhat intelligent way.
Smart endpoints, dumb pipes, right? But this is why ESB, the term ESB fell out of favor, right? Because it got too associated with that pattern or that practice.
Exactly, and that's why now, bottleneck, monolithic, etc. That's why we now use the term integration platform. That's why we use the term iPaaS. Although I started to actually hate this term. Because it's an umbrella term. An umbrella term because an integration platform or an iPaaS means two different things. Means either an integration broker or an ESB. And if you put them as one term, people stop differentiating between those architectural concepts. Integration brokers is something different than an ESB, and definitely different than message brokers. And that creates all sorts of wonky confusion in the field of integration architecture.
Well, and it gets worse because there's also products out there that describe themselves as service buses without the E, which is, again, a different thing. Azure Service Bus and Service Bus in the .NET space describes itself as a service bus, but definitely
Azure
not
Service Bus, as far as I remember, is a message broker, basically.
It's a queue-based system. It's kind of loosely analogous to, in the AWS world, SQS plus SNS. It's got the topics and the queuing baked into the one sort of service offering. So you got service buses, you got enterprise service buses, you got integration platforms, and I think historically these things just get defined by vendors as they come out, and there's this mismatch between, not a mismatch, but a constant churn between terminology as it's presented by technical people who are notoriously bad at naming things, technology as presented by marketing people who have an agenda when they're presenting it, and then the sector ends up with diffusion and confusion around what these terms all mean.
Absolutely,
which is why I'm a big fan of trying to get back to first principles and looking at what are you actually trying to do? How does this thing actually work? And let's forget a little bit about some of the labels attached to it.
Yeah, because throwing tools at a business problem never solves the business problem. So basically, you first need to understand that business problem, and for that, then choose the right tool for the job. So, okay, people are throwing Kafka. I agree with you that you can implement EDA with Kafka. The question is, should you? My argument is always, yeah, you shouldn't probably, because it's going to be a very problematic and expensive and over-engineered thing. The question is then, how do we differentiate, and for what use case, where do we use what? And I think that's the key aspect.
We have a strong opinion about this over where I work, and we see, because Kafka did kind of come from that native data pipelining, big data type of use case, it functions very well in that space, in the analytics space. If you're funneling all your clickstream data, all your transaction data into analytics tooling, it functions great in that regard. And I'll grant Kafka that. But what it doesn't always do well is kind of work in a very heterogeneous type of environment where you have many-to-many style communications. If you have 1,000 apps and they all kind of need to talk to each other, request reply is not a natively supported kind of concept. More operational communication. And so that's how we differentiate, is operational versus analytical. There's some overlap, obviously, as Chris said. You can take Kafka and build stuff that it wasn't really meant to do by engineering things. There are probably better choices out there for different use cases. So.
And I think so for me, one of the things I dig into the talk is okay, well, why is it better in those scenarios? And my analysis of it was that the reasons have a lot to do with how they handle failures, how they handle endpoint failures, how they handle message failures, the concept of dead letter queues, and it kind of speaks to how much of a design consideration was it when they were designing these brokers around treating each message as a critically important thing that must be processed versus treating it as just a component of a stream that maybe you drop a message here and there, it doesn't really matter. And I got pushed back on that, because obviously you can configure Kafka to operate in a mode where it's critical to process each message, but you do have to do a little bit more work around it to make that happen, and it's a little bit less opinionated on how you should do it. It doesn't sort of hold your hand, whereas most queuing systems will come baked in with the concept of dead letter queuing and automatic retries, which is sort of well, when you think, why do they have that? It's because they care about the message. But they don't always advertise that on the tin. They just sort of say, oh, here's a feature around retries, and they don't guide people to understand why you should care about it. What are the business circumstances where that matters? So that was for me one of the big ones. Then there's scalability, and again, Kafka has mechanisms that can help you with scaling out your consumer side. And in fact, it became well known for being something that's about high throughput, right? That became a lot of people were oh, well, we've got such high throughput, we need, we need to use Kafka. Well, these days, honestly, the queuing systems will compete with it on raw message throughput. But yeah, you mentioned consumer groups, which is actually another interesting thing from a terminology perspective, because in Kafka, the consumer is the node, and a collection of consumers working together is a consumer group. So interesting, think about the language there. What are they prioritizing as the consumer? It's a very technically oriented viewpoint that the node is the consumer and a collection is a group of consumers. Whereas when you look in environments where people are focused on operational, the singular term that they tend to use is the service, which is a logical concept for a collection of nodes that may be scaling up or down. So you've got these different perspectives that's revealed through the language. What are you prioritizing? What do you care about? What is your what is of interest to you. And then the other one I find interesting on that perspective is even just the concept of what is an event versus what is a message. So I've got to say, well, a message is like a database record. It's agnostic to its meaning. It's just a packet of data. But an event implies some logical interpretation of what that means, that it's a fact about the past, and then you can contrast it with a command, which is a statement of intention about the future,
or a document,
which is like saying, or a document, but a document, or it could be like a document, like a event carried state for transfer type situation.
And then on top of that, we have a difference between technical events and business events, where business events are a lot thicker in meaning, or technical events most of the times they reflect business events to some extent, but might be more granular in meaning than business events. So one business event might trigger multiple technical events, and this all goes into all sorts of wonky
and then you got integration events
conceptual
as another
problems.
concept that pops up, like it's an integration event versus a domain event. Well, they're all kind of domain events if they reflect a thing that happened in the domain. Like, how are you thinking about that? And then you got people who go, well, none of this is an event, because actually an event is something that I put onto my stream. Well, what do you mean by stream? Oh, I mean something within my event store because I'm doing event sourcing. It's like, oh God, another usage of the word stream and a different interpretation of the word event. And actually there's an interesting etymological history there. So when you talked about event-driven architecture, you can actually trace the word event back older than that, because one of the very first concepts of events in computing at all was the IRQ in old school. No, not even callback, even predating that, like in very low level in like the CPU. You've got the CPU executing a series of instructions, and then you have like some peripheral that needs to interrupt the CPU, and they had this thing called an IRQ, which is an interrupt request channel. And those of us with enough gray hair will remember having to configure, is my mouse on IRQ 5 or 7, and is that configured in the operating system appropriately? And that's a kind of event, right? Because that's like, you've got your primary system, which is the CPU running the operating system, and you got another thing, the peripheral, the mouse or the keyboard, that wants to broadcast an event that needs to get handled at a time, and then that transferred into, like, when they started doing Windows, or not just Windows, but like sort of GUI operating systems, and you have like an event bubbles into, you have event handlers within your sort of thick client software, like on-click events. So again, that's a concept of events playing out in a different way.
On-click.
Those are all events.
On click, all events, because they're this idea of like something happening, a fact about the past that needs to be handled. Not necessarily always broadcast, but still this idea that there's sort of decoupling, because the mouse doesn't know what it's plugged into, but it's advertising that it just moved or that there was just a click. And that's a common pattern when you start to see events being used everywhere. And I think a lot of us in sort of the system design space have this sort of tunnel vision around what is an event, without recognizing that actually there's like many other contexts within which people use this word, and there are some commonalities to it, but it's not necessarily the thing. Oh, someone's love harding IRQ 7. Oh, sorry, dude. Sorry for bringing back the trauma.
I mean, but, I'm not as old to remember IRQ 7, but I did interruption events when I was programming in assembler in the university. So basically the same thing in that sense, because you're literally programming a microcontroller to work in a specific way. That's the analog. Yeah, so that's the events are very, very coming from literally from hardware. But if you look at
in the software side, the observer pattern is exactly this. For those that remember their Gang of 4 design patterns, the observer pattern is the GUI event, right? You have a subject, which is your button, and then you have observers, which is you, the app, wants to register yourself with that button and say, notify me when you have changed state. And that is essentially the publish subscribe pattern, kind of within a small amount of software.
Single process.
However, there's a coupling there, because the subject now needs to keep a list or a record of all those observers that it has to notify. Therefore, it's coupled. Whereas with a publish subscribe broker, a broker in the middle, that acts as a somewhat, I mean, Carol can argue with me here, but you're decoupling the subject, the producer of that event or that data, from knowing how many things, where it is, right? The broker takes care of that kind of delivery. So for those that come from the software side, a callback, that you're registering with, you could have multiple ones. That is pub sub within your JavaScript app or whatever it is. So.
Yeah, and then you do have like, sorry, Carl. Yeah.
I'm gonna play nice, and I'm not gonna call Vlad Kononov right now to scold you, but
decoupling comes in different axes, man. So
it's not decoupling. It's a bit different thing, but yes.
Well, it depends.
Basically, lowering the knowledge.
Your definition of coupling.
Yeah, but it's like.
Should I take Vlad Kononov's book off the shelf?
Sure. Sometimes when people hear the word decoupling, they think, "Oh, we're like disconnecting." We're eliminating the coupling, and I think it's fair to say, I think it's fair to use decoupling the way Aaron did. If you're saying, well, it's about reducing the coupling pain, as Vlad would describe it, because it's like, yeah, there's less, there's less ways in which this can go wrong, or less ways in which it can cause you pain. So that is more loosely coupled. It's less coupled. It's decoupled. We slip down the scale a little bit.
Decoupled. It helps.
It's not complete, like because you think about coupling in a mechanical sense, like train carriages are coupled together. They use the word coupling and then decoupling the train carriages is like literally ripping them apart and disconnecting them.
And literally,
so
this
we're not
works
talking
the
like
same way
that.
in software.
Yeah,
it is the same way in software. If something is coupled, that means it communicates. If it's decoupled, it doesn't communicate. And then coupling is a spectrum of aspects. So, well, the message broker still couples the two systems, modules, whatever that is, because they still communicate. So they are still coupled, but it's a looser coupling because of the distance introduced by the message broker itself.
Well, the responsibilities of each component, right? I mean, the producer doesn't have to know where it's going. It just sends that one piece of data. The broker now has that responsibility of distributing it, persisting it, retransmitting it, et cetera, right?
Absolutely true.
Saves a lot of when you don't have if you have a non-brokered communication peer-to-peer. When you start with just two apps, that's pretty simple, right? Just a TCP socket or whatever, a REST post. But now you have 2 or 3 or 5 or 10 things all wanting to talk to each other, and then it's like, oh, that guy missed it, but that guy, it's like it gets really hairy.
Yeah.
So
well, and then you've got like webhooks, right, as an example of events as a pattern playing out using just HTTP, point-to-point HTTP. And there's another one that I came across actually was very interesting. I was watching like some old conference talks, and Jim Weber, who was involved, he wrote like one of the books on REST back in the day. He was a big advocate for what you would call like event distribution following the RSS protocol model, which is that it is the responsibility of the producer to maintain a history of the events, and the consumers poll for new events directly with the producer. Because you remember RSS as the like syndicate, really simple syndications, the way that like blog posts would be published out there. And it's like, obviously everyone used to have their blog aggregators, like feed readers and so on. And, obviously they're not pushing out to like millions of consumers when there's a new blog post, but they maintain a structure where they can poll for like what's new since this point. And that was a concept that a lot of people thought was, and Jib was pushing that, saying, oh, actually, we should get rid of this middleware. It just adds operational complexity, and we should have structures that allow the publishers to maintain the history so that consumers can just get what they need. And I think that kind of thinking fed into some of the Kafka design, because that is kind of more how it works, where the consumers have to say, give me the new messages since offset X, is directly how the Kafka API works under the hood. And that's kind of how RSS used to work. So there's that
puts a lot of onus on the, for the RSS stuff, it puts a lot of onus on the publisher right here. But Chris, just like you made I wanted to rewind to make a comment about something you said earlier, and you kind of just almost fed into it with regards to kind of how queuing-based brokers handle each message, as a critical piece of data, right? Whereas Kafka is more kind of lower value data, just streams of data. It's also on the consumer side, right? Where in most queuing brokers, you acknowledge each individual message one by one, and they're removed from that queue, not to be processed again. Whereas with Kafka and other kind of log-based brokers, you'd have to do this checkpoint on occasion, was every second, every 10 seconds. And there's no concept within the broker that maintains, I've already sent you this data. So if you have a consumer crash and restart, it goes back to its known checkpoint 5 seconds ago, which could be tens of thousands of messages that you now have to dedupe to figure out if you've already processed it, right? So
you can configure, you can change the configuration on the checkpointing, like you can explicitly checkpoint
every second
message and so on.
Yeah.
Well, you can actually do it
it's
after
not built
each
for
message,
that, right? Performance would probably suffer
it's not.
if you're doing that.
It's absolutely, and there's defaults and sensible defaults and all that kind of stuff. So I totally agree with you, your point.
Okay. That puts us in a perspective that basically, if you look at Kafka, it's not basically that built for that real time processing per se because of the
pretty real
failovers and
time.
whatever.
It's pretty quick.
It can be
Yeah.
pretty quick.
Define
but-
real time
but
now. Now it's
when it works,
Microseconds?
but when it fails,
Mm.
you're then having issues of that high performance speed that you actually can miss because it's not defined, because it actually stores all the messages on a partition. Then you have a problem that, okay, where were we? We have no marking of those messages actually, because the marking of messages is actually on the consumer side.
Well, so
and then
this is an interesting thing. It is managed by the consumer, but stored back into a separate topic in Kafka. And then a lot of people say, but hang on, I'm not managing it. Oh, well, you're not, because the library is doing it for you. So the Kafka high-level consumer library is all of the smarts is baked into that consumer library. So a lot of the smarts that in a queuing system are baked into the broker itself. And Kafka are baked into the library. So the developer experience for a lot of these things is like, actually, I don't have to worry about it. The fact that it happens to be running on the consumer side is less of a concern for them, because they're not it's kind of transparent to them. But until it suddenly isn't transparent, when you have an operational issue, where you're experiencing either message drops or head of line blocking, depending on how you've configured the brokers to operate, and depending on what failure mode you're experiencing. Because like a failure mode where like a message handling throws an exception and you just like ignore it, is going to lead to a different situation compared to a failure mode where the message handling leads to a server crash, like an out of stack, a stack overflow or out of memory exception, because then you definitely spin back up and you're starting at the last persisted checkpoint. But if you just like ignore the exception, which is, sometimes people do that, whether or not they should, then actually you get a chance to process the next message and you checkpoint it, and then all of a sudden you've dropped that message and without any kind of visibility that you didn't even process it. So there's these subtleties between like the specifics failure mode and how the system's going to behave. How you're going to witness the behavior of the system at a higher level, that if you're not familiar with the under the hood mechanism around how the client process is communicating with the server process, you're going to be confused.
Yep.
This is one of the key problems here about what people experience is that basically a lot of people design only for the happy path without actually consciously thinking for what is my failure mode, what is my error handling, and I find it like really easier if I have some control over that error handling, like for example through acknowledging and negatively acknowledging a message on a queue when I work with a queue. That makes it for me possible to actually properly manage the behavior of whatever I'm doing in the listener that collects the messages from a queue. Whereas if that's baked into a library and not surfaced to my error handling, that becomes a bit of a problem because it's hidden, and so it's not obvious, so people don't see it until they hit the wall of an operational problem.
Exactly.
Operational complexity is probably the biggest complaint that we hear about Kafka. It's not usually about performance. It's definitely not about developer getting started, which is really good. It's just a Java app. You just run it, download and run it. It's when the devs port it over to the run team and they hit a wall, they hit an operational problem, and their amount of visibility into the actual broker workings, which is pretty minimal because it's just a file system with a bunch of logs, is difficult, right? Recovering people that haven't used queuing systems before, the concept of a DMQ is not something maybe they're familiar with, but it's like absolutely critical in a proper enterprise integration construct where I'm trying to deliver this message, you keep crashing or restarting, and eventually I'm going to move that out so it prevents head of line blocking. It goes into a DMQ. I can then use special tooling to go and analyze it, a queue browser. It's the payload's wrong, or I'm going to just save it. I could maybe, the consumer hasn't been revved yet for the next version of payload. I can go and fix my consumer, redeploy, and then copy that message back onto my main queue, and things keep going. These kind of things are not available, as far as I know, in the with maybe with a lot of engineering workarounds. Yeah, a lot of workarounds.
Yeah, but engineering workarounds that have eventually been sort of conventionally formalized into like standard libraries that you can import if you're aware that they exist, and you're aware of the appropriate open source package that you can pull down that can help you with that. And there's some conventions that people have adopted around establishing like bespoke dead letter queues as like topics as the to fulfill the purpose of a dead letter queue. But even in that environment, I think it's interesting because when you have a message that is wrong, either because there was actually a failure on the producer side to produce it correctly, or the consumer, as you say, hasn't been revved. In a queuing world, when you replay that message after revving on the consumer, or you replay it with some manual tweaks to the content of the message so the consumer can process it. Because it doesn't store the history in the queue, you kind of get away with it. Like you replay it, it goes through the queue, gets processed, and you're happy, and everything's done. But with Kafka, if you do replay it back onto the original queue, you've now got the problem message in the history and the new message in the history, which is because they're both still there in the history. It's immutable history. You can't go back and change it.
Sure.
Which then intersects with another interesting thing, which a lot of people say, oh, well, what we like about Kafka is that it does have that full history, so we can spin up a new service in the future, replay the whole history of messages, and sort of catch up the state. And I'm like, you're not going to really be doing that for more than a couple of months worth of messages, realistically. Well, A, it's going to take a while, but B, like, are you really going to add support in a new service to like the historical schemas from 5 years ago, from 10 years ago? Like, you're just not going to do it. And you probably won't have that data, because eventually they're going to have like compacted the topics or whatever to save space. And, so I think it's sort of connected to that point, which is another myth in the space. I think that people think that there's all this value in having the data stored there forever.
For analytics,
like, hey, you're probably not going to store it forever.
Yeah, for analytics, I think there's a lot of value, right? You're training models, you're training algorithms, like being able to rewind and play a week's worth of data. That's great. There are queuing brokers out there that have replay built into them, as a feature, where you can say, this queue's subscriptions were incorrectly configured on Monday morning, so I'm going to go and tweak them and now replay everything from Monday at 9 a.m. and it's as if it's a live stream. But it's definitely not. It's in Kafka world. Replay is the recovery mechanism, right? It doesn't have this redelivery act by message kind of thing. So like replay is just how it recovers. And most
interesting when you call it replay, but when you, as a metaphor, I find replay a bit misleading in that context, because what's actually happening is you're just resetting your checkpoint, you're resetting your offset, and you're going back into time and saying, actually, I was requesting the messages from offset 100, and now I'm requesting messages from offset 50, so I'm going to get those last 50 messages again. And when I think of replay as a metaphor, I think of like, I'm going to replay this song, like Alanis Morissette's, because it's great. I'm going to replay that song. And so there's actually, like, to me, that implies something happening in the broker to cause that to be replayed. But again, in Kafka, that's not actually what's happening. It does eventually result in those messages getting reprocessed, if that's, assuming that's what you wanted to do. But it's interesting that you say that, like, some broker systems or queue brokers do support that, because I would say that's not typically a capability you see in queuing systems.
It's not. Yeah,
not our responsibility.
We only put it out about 5 years ago. Before that, we did have third-party products that we would recommend, especially in like the investment banking side, like that wanted to capture all the trade prices. So you just offload that as a consumer, and they would be able to republish to a dedicated topic or queue. But yeah, we built it into the broker, and there are use cases where being able to rewind. If your database corrupts, you kind of put it back to its known checkpoint, and then you want to say, all right, everything since then, go. And it's nice if the broker can store that. It obviously adds a bit of load on your broker system to have to store
quite a lot.
Well, it's the perfect slow subscriber, right? Slow consumer. It has to store everything. It's a queue that just keeps growing and gets trimmed off at some point. But
there must be limits, right? You can figure like a storage limit or a time limit.
Yeah. Well, always. There's no such thing as an infinite disk. Not that I've found yet. So.
Not yet.
Although for many people, Amazon's SQS can be treated as an infinite disk. Like,
it's kind
for
of,
most people, you kind of never really have to worry about it.
I've seen situations where people literally treated Kafka like a database. The partitions were literally databases.
It's a streaming database. Yeah.
But they treat it like this is not going away. This is persisted forever and ever and ever, and we're gonna just use it over and over and over again because we can, and we can treat it like a relational database. We could just going to use it that way, only with different mechanisms, because it's a partition and it's Kafka. It works to some extent, but one aspect that goes with that, what we were saying earlier about the developer experience is great, the performance is great. When we hit the wall of operational problems, then we're having issues. And I've seen a bit of a socio-technical aspect to this, that because Kafka is very heavily marketed as event-driven architecture tool, people start with Kafka. The moment they hit the operational problems, they abandon Kafka, for example. That's happened so many times in various engagements that I had with different clients. that later talking about anything event-driven results in an immediate pushback that
A
we're
dirty
never
word.
going to be doing event-driven ever. It's like, okay, what were you doing to have such a strong opinion about event-driven architecture or event-driven integration flows? It's like, yeah, we did Kafka. Okay.
It's interesting that that's been your experience, because my experience has been more they hit the operational issues and they just double down on working around them and building their own sort of
It's not the dev's
Byzantine
problem.
sort of set of solutions around the operational problems. You know, to the
Sure.
point where I've seen organizations where they have their own name for the broker, and they said, oh no, we don't use Kafka, we use, you know, tool widget X or whatever they call it. And then when I dug into it, it's like, oh, tool widget is just like a bespoke wrapper around Kafka. They actually are using Kafka under the hood. They've just put so many like structures, homegrown structures around it to protect themselves from these situations that the devs didn't even know that Kafka was actually hiding under there. Or some of them did, but not everyone. Which is
yeah, but it probably depends on the overall maturity of IT in an organization. As a consultant, I mostly unfortunately work with companies that have somewhat of a low maturity in terms of organizational maturity or IT maturity. There may be some clever people in IT, but that's not enough to handle all the problems that they're having organization-wise that spawn into technical problems underneath later.
Not everybody has LinkedIn scale or Netflix scale, you know, like it's like, oh,
obviously.
they can do it, we can do it. And it's like, not really.
Nope,
it's
not really.
There is a lot of engineering involved.
So if you don't have that maturity to be able to handle everything and actually have time to figure out how to work around this so that you can build on top of this something that will work for you, then it basically becomes an operational bottleneck and eventually gets abandoned. If you have a bunch of clever people and they have sufficient time alongside all the business projects that they, you know, business as usual need to handle, then perfect. You have capacity to actually solve those problems and figure out the best way to handle this and to use this tool in your context. But a lot of organizations are small. They always have not enough people, and they still chose Kafka, and they got burned, and they are not able to solve it because they are not able to hire people that have Kafka expertise. They're not able to hire people that know how to handle all those additional things. And then that results in a hatred towards EDA, whereas they just used Kafka.
Yeah, it's this conflation between the things.
Like same thing like with ESB.
Yeah.
It's a similar aspect like ESB. Now, people hate ESB because of the failures of SOA, but ESB is a sound concept. SOA architecturally is a sound concept. Organizationally, not always. But again, it goes down to operational maturity of an organization and its IT to be able to handle this implementation and handle this operationally and not deviate from it and introduce some strange things. And that becomes quite a number of problems then.
So it's interesting you say SOA, you brought that up, because I'm actually really like SOA, like in terms of like the role it played in changing the industry's thinking around this stuff. And what I find interesting when you look at SOA and microservices, like the original literature about both of those things, you know, they both have a lot of principles in them. You know, people are saying this is what you should do to be doing SOA, this is what you should be doing to be doing microservices. And in both cases, there's one of the key principles is referring to the business domain. So in SOA, I can't remember exactly how it puts it, but it's something like, you know, these should represent a business capability. You know, these services should represent a business capability. And then in the microservices, they should be modeled around the business domain. And in both cases, when you look at where that sits in the collection of principles, it's often like framed as being the most important one or one of the most important ones. And yet when you look at what the industry did with these principles, they prioritize every single other one instead of that one. And I have a hypothesis as to why that is because all the other ones are repeatable solutions, which means vendors can sell you a product that helps you with them. But a vendor can't sell you a product that solves your business domain. That's the thing you have to do. You have to understand your business. You have to understand your domain. You have to design your system to reflect your domain. And then you have these vendors coming in and selling like enterprise service buses or brokers or whatever. And because they could solve all the other issues of the the SOA or microservices paradigm, that's what gets all the attention and bandwidth and conversation space. Whether it's observability or deployability or, like to pizza teams or whatever it might be. And everyone talks about that. And that becomes like what people associate with the concept of microservices became, it's a microservice because we can deploy independently. It's a microservice because it scales independently, or it's a microservice because we've got different technologies in different parts of the stack. And I'm like, and not once have you talked to me about your business domain. Not once have you told me, it's microservices, because we've oriented around our service design, around the bounded context, or around the kind of subdomains that we found from doing the domain modeling. Did you do any domain modeling? I'm sorry, don't know what you're talking about. But we can deploy independently. Well, great, because you're actually probably not going to be deploying independently because they're so fucking coupled. You're going to have to deploy them both all the time. So
I think that in that respect, as far as I remember, Barry O'Reilly did say that we as engineers, we love complexity, and business domains are not interesting in that sense, because there are business domains that are very complex, true, and they can be very interesting, but from a perspective of implementing them in code, they're not that interesting for a lot of people. So we're going into complexity.
I have an interesting thought on that. I don't think it's not that they're not interesting. I think the problem is that to find out what's interesting, you have to actually talk to other people. So vendor can't sell you a box of maturity and culture. Totally right. But like to discover what's interesting in the domain. All domains are interesting to me. I love learning new domains. I love understanding new domains, and they're often incredibly rich and rewarding to dive into. But the problem is that to discover that, you have to talk to other people. Whereas to solve the technical problems, you don't have to talk to other people, because you're a technologist. You understand them implicitly. You are the expert in the domain of like building an operational or an uptime, caring about uptime or caring about deployability, caring about CI/CD. You're the domain expert, so you can just solve it. You don't have to talk to anybody else. As soon as you have to talk to somebody else to understand the domain, you're like, oh, that's not very interesting. I'm like, come on, guys, get your heads
I mean,
that's actually the whole freaking point. Like that's the thing.
That's literally what I heard as a junior developer back in the day when and people said, like, I didn't go into computer science to study computer science to talk to people. And I'm like sitting here, for the last few years, I'm like realizing how absurdly stupid of a notion that was. Because if you're not interested in the business domain that you're implementing for, you're basically baking in your own assumptions into code, which will result in a failure of that software to support that business domain. And we all need to build software that has purpose for the business domain, because we all work in specific businesses. Unless you're building that software for yourself, then you understand your business domain because you're building it for yourself. But you're not building that software at your job for yourself. You're building it for that business. And that is a completely different thing. So you need to talk. And even me as an integration architect, and I'm integration architecture and iPasses, and they're not specifically domain partitioned. They don't really oscillate anywhere around the core domain. iPaaS and integration platform, that's never a core domain for a business. That's always a supporting domain. So my work is very much domain agnostic. I can go and do my work in a completely different industry and I'll be perfectly fine. But it's amazing to learn about that specific domain, because learning about that specific domain actually helps you design and develop better integrations for said domain.
For sure.
Because understanding what is the business process, what is the logic behind certain objects popping up as data, etc. This amazingly helps. But if we, instead of understanding our business problem, we just dive into and throw a tool at it, well, obviously, we're not going to cater to the business domain, which is going to solve all the technical issues and the problems that are there. But if it's not aligned with the business domain, it's going to fail anyways. And that's basically what is the failure of SOA back in the day, what is the failure of EDA when people try to apply a message broker, or operational message broker, or a log.
And the failure of microservices in many respects. Like it's the same kind of pattern that I'm calling out there. But I want to be clear, like I don't see it as a failure of SOA or microservices or ESBs in and of themselves, right? It's a failure of the industry to apply them appropriately. But the concepts were valid, and like the things that led to people proposing them as concepts were very, very reasonable, and I think still have merit. It's just, as an industry, we're kind of really bad at like deploying them appropriately, because we get stuck on these technical ethics. And I also want to acknowledge that, like, I know I kind of went hard at devs that are not interested in the domain there, but there's also a lot of contexts I've seen where it's actually not their fault, right? They want to know about the domain, and they get told, no, get back in your box. That's not your problem. We'll tell you what to build. Don't ask us questions. We've got a team of product and BA people over there that are coming up with the requirements. You just do what you're told.
So it's architects and
it's a very very disempowering. And I think sometimes there's like a learned helplessness there, where devs are like, well, I tried to care about the domain. I got told to shut up and go away, so I don't care anymore. So I have a lot of empathy for that. I don't, even though I kind of always trying to G up devs to care about the domain and say, no, go and ask these questions, go and talk to someone, go and sort of have these conversations, do some event storming, like just trying to learn about the domain. I do want to acknowledge that there are many organizations with cultures that actively like fight you on that and make it hard for you. And that's pretty tough.
Very true. I talked to a lot of devs that actually want to learn about the domain, and they're just literally barred from learning about the domain, and it makes it extremely hard for them to do their work, because they don't understand why they're doing certain things and for what they're doing these things, and that makes it horrendous. Well,
even getting outside of business domain stuff, like, I mean, just because we're doing integration, right? You have different teams producing and sending data. I've had customers where they have one team that is building the publisher, they have another team that's building the subscriber app, and they never actually talk to each other. They produce a shared document with topic structures and payloads, and they just share that, but they never get in a room and actually talk about the other stuff in terms of like redeliveries or like, I'm like, how do you guys, like, you work in the same building, you're on the same company, but let's get together, let's get a whiteboard, and let's bang out some of this stuff. It's like company culture can be, anyway, it's just,
that's totally true. It's totally true. And there's a really interesting side effect of that I sometimes see as a signal for where that's happening, is organizations that have really heavily embraced consumer-driven contract testing, like PACT style. So where they're kind of saying, and because I've heard people say, oh, we had this problem, so we adopted consumer-driven contract testing. I'm like, actually, I like consumer-driven contract testing.
What is that? I don't know this term, Chris.
Okay. So yeah, it's really cool. The idea is, well, it's cool in a given context, but as you'll see, I think of it as also a signal that the context is operating suboptimally culturally. So what it is you've got some team that owns a service that has a contract. Maybe it's an API, maybe it's an event publishing contract. And then you've got consumers of that contract, so event subscribers or API callers. And the idea is like, well, we want to know as the owner of the contract, if we're making a change, like, are we going to break stuff for other people?
Yeah.
We've got a concept of how our contract is being used. But as we all know, like, consumers will find tricky ways to couple themselves to elements of it that you didn't think were important. So you might change something thinking that's not going to have any impact, but actually it does. And so the concept of consumer-driven contract testing is that the consumers write tests on the service based on that codify their expectations of the service, that they expect it to operate as a given schema, or to like publish the event at a given time, or after a given series of other events.
Hold on.
And then they register these tests.
With the producer.
This literally sounds like test-driven development.
Well, no, it's not, though, because the people writing the tests are not building the service. So test-driven development is where you write the test and then you implement it. In this case, the consumers are writing the test.
The test is externalized then, basically.
It's externalized. So the consumers are writing the test based to codify their expectations of the service.
And give it to the owner?
Register that test. They give it to the owner, but there's those systems that support that. So you can register the test with this consumer-driven contract testing structure. Okay. PACT is a really commonly used one. And so then when the service team deploys a new version of service, PACT will go and say, in the CI/CD pipeline, PACT will say, oh, what are all the tests that other teams have registered that I need to execute when this service is being run through its pipeline? It'll run the other team's tests against the service, and then that'll flag an issue. And because it's the other team writing the test based on what they expect, that'll flag an issue that the service team may not have even been aware of in the way which it was being depended on. And, I can see a lot of contexts where that's like a really helpful stepping stone towards solving the broader cultural issue, which is exactly what you were talking about, Aaron, which is that why are these teams not even talking to each other? Why is that team ignorant of, the dependencies that the other teams have on it? And I saw Seb Rose, who's one of the guys that came up with this, give a talk at Newcrafts a few years ago, and he explained the context within which they came up with it, which was a context where they had a back-end service team in Europe and a front-end team in America, who literally never spoke to each other, and they were breaking each other's shit all the time. And so they came up with this thing as a technical solution for the sort of socio-technical problems of these sort of teams that in the DDD world had a very close context relationship. They had different bounded contexts that if you did a context map on it, you would probably identify them maybe as even partners because the context or the domains are so closely connected. But they were operating culturally as like they weren't even connected at all. And so they came up with Pact as a technical solution to that problem. And I think it's like to me, it's like a Band-Aid, right? It's like it's a workaround for a cultural issue. But it's better than not having a solution at all. And sometimes a little bit easier to get going than to solve the cultural problems or the communication problems in the organization.
But, interesting thing is that when we think APIs, as in most people now think API is a REST, which is not really REST, just JSON over HTTP.
Stole that word.
Right, and as Einar Hust would put it, bless their souls. But if we think about, quoting from his talk at DDD Europe this year, but thinking about this, it's like people think about APIs, they think about the contracts, they think about something like, let's say, old school WSDL. They think about OpenAPI spec or just a Swagger, whatever, right? So they think about that. They actually understand that there is a contract. When people think about event-driven flows through like a message broadcast, whatever, right? They do not think about that there is a contractual obligation, which is even more complex than a contract with an API. Because an API, somebody defines that API, and there is a contract for that, and there's a consumer that agrees to that contract. Usually it's a point-to-point communication that is not necessarily reusable unless it's an API layer on a SaaS product. Fine. But there's a contract. The two sides usually should negotiate that contract. And they have a contract, so they have also some sort of a, let's say, SLA, use of data, if they're mature enough to acknowledge that data governance is actually important, etc., etc. When it comes to event-driven architecture, people don't really think about contracts. And there are contracts, and we even have a notation for that called async API to actually facilitate contracts, right? But they think like, oh, broadcast. Yeah, I'm going to send a message, everybody will consume, everybody will be happy. And there's no, round table for people to like, let's negotiate that contract. And agree to that contract. And then we end up with problems of model and contract coupling, where we change that contract as a producer of data, and then suddenly some people are annoyed because, and a lot more people are annoyed than in case of APIs, because we actually broke their stuff, right?
Sure.
A lot of people are not thinking about broadcasts and events in a contractual manner. There is a contract.
And I think there's a lot of people get really confused because when you look at EDA, it's often touted as being, well, it's great because the service doesn't need to know who its subscribers are. And that's exactly right. You can add new subscribers. You don't have to modify the service. It's awesome. But that doesn't mean the team doesn't have to know who their subscribers are, right? And I think a lot of people get really confused about that. They think because the service doesn't need to know who the subscribers are, we don't need to know. But actually you do, because they're your customers.
No, you do.
They're actually your customers. They're depending on you. The only reason you publish that event in the first place is because there's people that need it. And so you should be talking to them and understanding what they need out of it and when they need it and what they're doing with it. DDD has some tools to help with this in context mapping, like the upstream, downstream defines the technical relationship of, if you modify this, then technically the impact is going to flow in these directions. But then you've got the team relationships around, partnership and customer supplier and open host service that kind of give you more nuance around the socio-political landscape. And I think it's very interesting. Actually, there are environments where teams are aware of who their consumers are, who their subscribers are. And actually, even though technically they could change their contract and it would, and they have the right to do it because it's their contract, politically they can't change their contract because it would break 5 high-value, well-known subscribers. And actually, I think that's better if they're aware of that, than the teams that are ignorant and saying, well, hang on, we're doing EDA, so we don't have to care who our subscribers are. It's up to them to, come to us. And it's like, oh, God, not really. Like, they're your customers in most cases. You should be caring about who they are.
we've seen like customers that have, as their EDA use grows, they started off with an Excel spreadsheet of different topics that they had, and a Word document or Confluence pages that describe payload, and a Visio diagram to kind of show what was where. And as these things grow and get more complex, it just gets harder and harder to keep things up to date. Not to make another plug, but like Solus, we built a portal. We built an event portal specifically to kind of model what these API management tools did, where you can you have the payload contracts for this URL. This is the payload. You can do code gen off that again using async API, as Carol mentioned. And I don't know if it does kind of validation where if you change a payload structure, if it'll flag, because you can see who are publishers and subscribers. You model that out in this cool looking graph that kind of looks like this. Which was that way. This graph here on my side. That's what it kind of looks like. Publishing and subscribing with little arrows. You need that kind of tooling as you become more mature, more growth of it, and being able to find what's out there. And to your point, sometimes teams don't know who their consumers are, right? Because you publish on this broker, and that broker is chained to a number of other brokers in different geographies. It's possible that, and people are coming up with new ideas all the time, right? It's like, oh, I go and browse the catalog and I find some really cool shipping manifest event that's published. I have a great idea for an app and I do some work. So centralizing it to some degree, that kind of relationship between who is publishing and subscribing based on that it's kind of useful to keep in mind.
Yeah, as long as it culturally it turns into a conversation. We see that this event is here. Let's make contact with that team, let them know that we're using this, and make sure we're on their radar, and let's talk a little. Let's understand what their roadmap is. What are their future plans for this 100%. Event? It needs to. And just to sort of shout out to some alternatives, if you happen to not be using Solus, David Boyden's event catalog is another great tool.
It's very good. It's very good.
That people should check out, because that's sort of evolving to solve that problem.
It's pretty good.
That's the original concept of the event portal, basically. David was the first one to conceptualize an API portal for events in that sense.
First, before Solus.
QR code for.
I didn't know that.
I believe so. Yeah.
Okay.
I think it's a bold claim to say he was the first. I don't even know if he would claim to be the first, but I think it's definitely the first to get some traction.
Early.
But yeah, he was definitely the first to get a lot of traction on cataloging events, exactly like we do in API
and having
portals.
A portal for it.
Yeah.
And the thing I like about his tool is that it integrates with a lot of the schema registries and other data sources in your environment, so that you kind of don't have to document everything by hand. It gives you a scaffold to sort of get a lot of the information into the portal, and then it gives you the ability to layer on top of that your kind of bespoke documentation that you want to add to it, which I think is why a lot of people kind of valuable, because it does have a way of sort of keeping itself automatically up to date as things change in the environment, which is a big flaw of many documentation structures, that they don't do that. They kind of get stuck in a moment in time and then become obsolete very quickly.
And these types of tools are really becoming necessary, as the rest of the world moves to event-driven and real-time data movement. We're not batch-oriented systems they're still going to be around, but everything's becoming more real-time, stream-based, push-based notifications of business events, of customer events, all that kind of stuff. It's maturing, and we need these kind of management tools to help kind of keep track of what's where and where it's going and what's it called and all that kind of stuff. So,
okay, I'm going to correct myself.
We've gone away from Kafka quite a bit. A second. Okay.
Yeah. But Solus was announced. The event portal was announced in October 2019, while event catalog was January 2022. So, I'm correcting myself.
We're a commercial product,
we jumped away a little bit.
We're not going to be as famous as something open source, so that's.
Well, it depends. I mean, there are open source projects that are completely not famous and commercial.
No, just because you're open source doesn't mean you're famous. It helps, right? So get.
Well, I think what helps him is that it works. Does the Solus portal work if you're not using Solus?
Yeah. We have a Solus portal for Kafka as well. So that was a big push we did, because we find.
Yeah. Right.
Yeah. Nice. Check it out if you want. Again.
But we went away from Kafka per se. But basically, all of these are aspects that are basically also impacting how we use Kafka as well, because those socio-technical aspects, they're very important to Kafka as well. If we don't understand who our consumers are on Kafka, that's going to be the same problem.
I think we've covered a lot of examples of cargo culting, though, like people just adopting practices without understanding the context and why they should be doing it.
And then
where it comes
The
from.
one thing I wanted to go into, which is also related to Kafka as old log brokers and all operational brokers, is the concept of ownership. Because we tend to also in API design, we tend to think, oh, that team has designed that API, they implemented that API, they own that API,
Sure.
right? In that system, that API belongs to that system. There's clear ownership. Whereas we do not think about queues, topics, partitions as APIs, where they are APIs, and in fact, they're a protocol that hosts a specific. They are an API to a specific application system. You put data in one way, but this is a sort of an API. And then if you look at it from a perspective of ownership, who owns that API and why and when, it's a crucial aspect. And if you're doing queuing through just a message queue, well, the queue usually belongs to the receiver of that message.
Consumer. But it's the producer. It's the topic. It's the topic and the mess, or the destination and the payload. That's the owner of the data, in my opinion. Like, it's not the.
Yeah, but I think to Carol's point, like the API is more than just the schema, right? The schema is part of the API, but the API is the channels and the access protocols and it's the whole thing. And sometimes like the API is like
it's very clear.
Like in the REST equivalent, it's not just the payload schema; it's also the URL and the methods that you accept and the exceptions that it might throw the error codes. So in the event-driven world, like the topology of the topics and queues is part of the API, and the schema is part of that as well. I totally agree. The producer or the publisher. Actually, that's another interesting terminology, like whether you call it producers and consumers or publishers and subscribers, either or in a way, but it often tells me a lot about your context that you're thinking about. So I think of producer and consumer and message as being a very like runtime oriented view, and publisher and event and subscriber as being a very domain or logically oriented view. Because publish subscribe is like thinking about the logical intent, and produce consume is thinking about the activity that's happening. And so in the database world, as an equivalent, like we talked, like you have tables and records as like the technical or the the activity that's happening. We're writing data to a record in a table, but then you can layer an interpretation over that, which is like, oh, this table represents an entity type, and each of those records represents an instance of the entity. That's a logical interpretation of the data. So publish, event, subscribe, or send, command, handle is a logical layer of thinking about the intention, versus produce, message, consume is just the technical layer of the flow of the data.
I've always heard them referred to, like, if you're doing queuing, right? This is kind of maybe JMSy. It's produce and consume is very queuing. Publish, subscribe is topics and pubs up. So, but
yeah. So that is there. But if in the Kafka world they use producer, consumer, and they're talking about topics and events. So there's that's why I kind of think about produce, consume. So I know it's my personal take.
Makes sense. No, even in our
APIs,
APIs, it's producer and consumer. It's receiver sometimes too, as well. Sender and receiver is sometimes you see those terminologies. So,
especially with point to point.
Going back to
correct.
Going back to ownership per se. If we're looking at we're looking at an API as a broader concept than just a REST endpoint. That API is an application programmable interface, which can be literally anything like SOAP, REST, JDBC, ODBC, OData, JMS, AMQP. These are those protocols that can be used to implement an API. And if I'm looking always from perspective of those socio-technical aspects, who owns what? And I'm looking at a queue. A queue for me is, in a queue you have only one consumer that can consume logically, right?
Well, one because
the message
consumer,
will be gone,
or one consumer group.
One logical consumer.
So to be precise.
Yes, because we can use a queue for load balancing, so we can have multiple instances of the same
competing consumer,
or computing consumer, depending what we use. But the usual, we have a group of applications of instances of the same application consuming from one queue to load balance throughout
each message
round robin style, right?
Sent once,
But each message is sent once. So if I look at it from that perspective, for me, in the usual use case, the consuming party, this is an API of that consuming party, and they have ownership over that queue and ownership over the contract of that queue because they're the only ones consuming. But multiple applications can write to that queue because a queue is 1-to-1 or many-to-1. right?
Mm-hmm.
When we have a topic, that the complexity of ownership shifts drastically, because to the topic you can have one-to-one, one-to-many, many-to-one, and many-to-many,
Mhm.
right? And then depending on which configuration you have different aspects of ownership. So, for example, if you have a producer producing an event, let's say we're having our CRM producing an event that the client did something. Oh, fantastic. Then they are the owner of the contract, and then rest of us are consumers of that contract, and we agree to that contract.
Mhm.
But a different example, you have, let's say, public entities. We discussed that with Chris just before the live stream. Public entities that they agreed that they're going to consume the messages in this schema, and they shared the contract between one another, and then impose that contract on all the producers, meaning all the, let's say, companies need to file their tax reports, send them to this endpoint. This endpoint is a topic. It's going to be distributed to the tax
Interesting.
authority, distributed to something else. The ownership
Mhm.
on the topic shifts to the right side, to the consuming side, because they define what they want to consume. They share that between one another. They agree. So no one single entity owns that contract, but they share ownership of that contract, and that ownership shifts. And people really don't think about that. They
Interesting,
think
yeah.
about it like, yeah, this is the owner. This is. They think about it like the technical team that hosts and manages this message broker is the owner of those queues and topics. Period. But from a logical perspective of use cases and being fit for purpose on a business purpose and understanding the domain, the ownership is actually elsewhere. It's not with the team that manages the broker infrastructurally, but it's with the team that actually consumes or produces to set structure on a message broker.
Who owns the
that's-
async API
it's the
schema?
same-
I mean, because that could be set up as either a send or a receive, right? So in your case, the tax authority, they're the owners of the schema, and they define the inbound topic and payload and format
Exactly.
or queue name or whatever. And in the other way, it's
and
like
this is-
sender.
Yeah, and this is based on the political power. So that socio-technical aspect that we often look at from a perspective of context mapping and domain-driven design. Who has that political power in this interaction between various systems, entities, modules, whatever that may be, microservices? It doesn't really matter. We need to look at that, because this is where who is dictating. Is that a partnership? Is that a open host service? Because a queue can be an open host service. A topic can be an open host service in that regards.
Yeah,
and this is
I think it's interesting, Caroline. What the scenario you're talking about is extra interesting, because it's when it's not just the tax authority that is receiving that data, right? Like, because if it was just the tax authority, then that wouldn't feel like event driven. It would just feel like a traditional API where everyone's funneling, many to one into the tax authority queue, and it's clear that they own the schema. But it's a situation where the tax authority and the like business registration authority or some other 3 different government departments have all agreed that they want that data. They've collectively defined the schema, and then a whole bunch of different producers need to produce that same schema. And it is still a fan out in a way, but it's like many to many, because it's going into the broker and fanning out to the 3 different government departments who have all agreed on it. And so it doesn't belong to any one of them. So it is still an event in that sense of like some sort of fan out or publish subscribe, but with multiple even logical publishers. I think that is definitely one of the more complex topologies that you would come across. Like, if you can limit yourself to say that the producer owns or the publisher owns the schema, you're definitely going to make life a lot easier for yourself in a lot of contexts. But you're right that there are scenarios where you can't do that, and it's just not the right way to do it. And I think having the mental model that disconnects between ownership of the schema or the API and ownership of the operational runtime, and that's helpful to be able to make sense of that situation.
The same goes to ownership of the application and ownership of data. These are 2 semantically different concepts, and people do not often differentiate between the 2, and that creates all sorts of different problems, because they think it as one. Well, that application owns its data. No, the data is coming from the other application. They are the master of data. You're only consuming that data and working it into your business process, but you need it on demand. So that makes it very different. You're not the owner of that data. You consume that data. And these concepts are not exactly easy anywhere. And for the matter of this aspect of broadcasting to like public institutions that share a contract between them, they all agreed on a contract. This is where we actually have a little bit of problems in terms of context mapping, because interchange context was never properly defined in that purpose. We sat down and did some research on this, how to actually start naming this. So we figured this is a shared boundary interchange context, where there is a shared boundary that has no substantial implementation as an application, but they define a contract, they define what is the boundary. And
a
this is
ubiquitous
exactly
language
it
within that context, like the definition of the terminology and the meaning of the domain meaning of the terms and
is shared.
Data dictionary associated with it. Yeah. Super helpful.
Yeah, so it becomes agnostic from the individual institutions to some extent. They created a separate ubiquitous language to describe that particular contract. So it is not any of those bounded contexts. It becomes an interchange context, which is a separate thing only for the exchange of data, which makes it all the more fun, but very, very, very different from a perspective of ownership. And
probably every single participant in that ecosystem has a separate anti-corruption layer to translate from the interchange context into their own private context.
Most likely, yeah. Most likely, that would be the same thing to do, because they own their own bounded context, so they need to secure themselves, right? To not get too corrupted by the interchange. Which reminds me, when I was reading Mark Richards and Neil Ford's book, I believe that was Fundamentals of Software Architecture, they were describing the differences between a queue and a topic in terms of architectural trade-offs. And like, they were like, oh, a topic has a problem with security. I'm like, what the hell? Topic has a problem with security? Well, we have ACLs for all brokers, etc. How is that not secure? Well, it's not about the broker itself. It's about the consequence of using a topic, that all of these consumers of a topic, they share a contract. So data security is not a given, because they receive exactly the same data. And if you're working with restricted data, like GDPR restricted or whatever other regulation, I believe in the US and Canada, that's probably a very different regulation, that becomes a problem.
Unless your broker is doing a transform or something, but that's unusual.
Yeah, that would be very unusual, because that's introducing business logic there, right?
Correct.
Yeah. And that's another...
The old ESB.
I'll give you, Solus's very first product that we made was actually a content router, not a topic-based router. We simplified our delivery mechanisms, and in hardware, because Solus started off as a hardware company, we have a purpose-built appliances with FPGAs. So we're talking, very high performance. They actually implemented XSL style sheets in firmware, and so you published an XML document. It was originally for the telco world.
Oh, wow!
And you could subscribe as a full access or a minimal mobile device, and the hardware device would actually reformat the XML and give it to you and send it to you in whatever format you want. So kind of neat. But yeah,
content-based routing.
It's content-based routing. But no, and the routing part was, instead of subscribing to topics like with wildcards and slashes, it was XPaths. You injected as a consumer an XPath subscription. And so again, they built a content routing capability on XML in hardware, our original firmware guys at Solus. So nobody bought it because nobody needed that level of complexity or speed. So we had to pivot.
Talk about building a product, looking for a solution, or
100,000 XMLs documents a second. So
But that does spark an interesting thought in my mind, which is, we talked before about enterprise service bus and all the pain of like how they ended up getting business logic baked into them and so on. And I think that there's I keep coming back to this distinction between like the logical view and sort of the runtime view or the process view. And I don't want to get, I think it's worth disambiguating that in that situation, because the problem with those enterprise service buses wasn't necessarily that business logic was executing inside the enterprise service bus at runtime. The problem was clarity of ownership of the logical view of who owned that business logic and what who could change it, and when was the what were the catalysts for change and what were the consequences of change, who sort of would understand that. If you have an environment where there's a very clear structure around ownership, and the team that owns it can deploy their rules into the broker, and so the broker can execute the rules on their behalf at runtime. That actually eliminates a lot of those problems. So you get some of the benefits of being able to do translations and transformations in the broker, while still having clarity of ownership. You kind of get away from that sort of classic sort of noughties, 2000 era enterprise service bus hell that a lot of people were dealing with, because they gave you the mechanism with which to bake in transformations and whatever, but they didn't give you any guidance around how to structure ownership and clarity of like domain orientation. And so that's how you ended up with like people going to, why is this data turning out differently at the other end? Oh, it's because we had this issue, and someone that owns the broker like shoved a transform in there and nobody really cared or knew about it, because they probably just point and clicked at it at a point in time in production. Whereas if you have like deployment models and versioning of all of that stuff, and there's a team it's allocated to, that it logically makes sense, it's part of their domain ownership responsibility that they own that business rule and they're responsible for deploying and versioning it, actually like gets rid of some of that pain. And so that distinction between like the runtime and the logical ownership is a really important one that I think nowhere near enough teams like pay enough attention to.
And it's very rare. I used to work for T-Mobile back in the day, and that was the most mature integration platform I have ever seen in my life, alongside a very mature organization, an IT organization, which basically means there were safeguards. We're not putting business logic into our integration platform. There was some legacy business logic not written out into the systems, because previously this integration platform was an integration broker, not an ESB, so that there was a transition period when some things were slowly transitioned, and some logic was there baked in so hard that we couldn't really remove it that easily. But otherwise, without even knowing it, we had domain partitioning on an integration platform. So we had specific flows that were specifically tailored to domains. We had bounded context models alongside the integration platform, which were perfectly governed. And through that, we didn't have any problems with ownership, because the ownership was always on the side of the domain systems, and we only facilitated. We really built a interchange context that was devoid of business logic to a large extent. The more mature the platform was, the less business logic we could see. Where there were leftover business logic from the transition period from an integration broker to an ESB, these were always problematic, because these were literally baked on the old school notion, the original Sonic ESB concept of event-driven SOA, which was basically, yes, we have a central focal point of a message broker facilitating for transport, and then all the components of ESB are as close to the domain systems as possible. There was a transition period where in T-Mobile, where all those components were moved back to a monolith, because that model didn't work organizationally, because it sparked too many ownership discussions, too many ownership problems, and nobody wanted to take accountability and responsibility for different parts, to the extent that back then we didn't have API layers on every system. We had direct database communication, and each database had a dedicated schema for the integration platform, so we don't corrupt the actual production data. So there was an ACL. So this was well thought through. So there were staging tables, procedures dedicated for the integration platform to use, that never touched the actual production data, and there was this ACL guarding the production data from it.
In the data layer. Yeah, interesting. I have actually... Yeah.
And later on, when we centralized the integration platform back again, and we didn't have those integration platform components with those domain systems, well, we still had those schemas, but there were constant operational nightmares and arguments over who owns that schema and why. And we, from a perspective of an integration platform, we said, you own that schema because this is how you expose data to us or services to us. And the database guys were like, no, you own that schema. You make changes to that schema because we don't do anything with that schema. They didn't treat it as a part of their system. So
yeah. But it's interesting the language you use there, the database guys, right? And I think that it shouldn't have been the database people either. Like database people are responsible for the operational uptime of the database. It should have been the team that owns the transactional data that was, and whoever owns the ACL that copies or transforms from the operational tables into the contract tables. And I've actually
depending on
recommended
the
this one
team,
because
it differed.
yeah, but I think that's that's the direction that you'd want to head in if you're going to be doing it that way, because I've seen so many places where especially like they start building a system very focused on the OLTP database side, the transactional data, the operational runtime, the customer interaction system, and then eventually someone says in the business, we need some analytics, we need some data visibility, we need a data system. So they go and hire a data person. Data person comes and goes and builds a data warehouse, and they say, where am I getting the data from? And they go, we haven't got time, here's a read-only connection string to our database. And then they build a data pipeline that sucks the data out of the operational database. You've seen it, right? And then that flows into the
too many times.
And then those private tables become a contract implicitly without anyone really being aware of it. And I said to teams that are stuck in this, is like, as a point change to help you start to get away from this, treat those tables as a contract, and you, as the team that owns the operational data, you have to be responsible for separating between the tables that you want to use for your system and the tables that you're exposing to the data pipeline, and you're responsible for maintaining the transformation of the data from one to the other. And I said, you got to think about it like a DTO at the API level, right? Like you got the data transfer object. I don't know if you're familiar with that term, but people build within the software, you often have like your entity models and then your DTO models, which is like so that you can change your like domain models separately from your API schema. It's the same principle applied in a data layer.
We need an abstraction layer between.
We need an abstraction, and just the fact that it happens to be in the database is like neither here nor there. It's the fact that it's an abstraction, and there's a responsibility is clear of who owns it. And you said the data team didn't want to know about it, and I'm not surprised, because they're probably not responsible for the domain concepts that are embodied in that data. And it's the team that's responsible for the domain concepts that should be responsible for that.
It really depended on which system we were talking to. Different teams operated differently. The teams that were very legacy systems that had these dedicated schemas, they usually were very technically oriented, not domain oriented. And the architects working on that were very domain oriented, but not exactly the actual developers, operation people. They were very technically oriented. By the way, Aaron, that's why I'm always laughing at in conversations with you and other guys from Solus, that you guys are literally with micro integrations. You're literally recreating event-driven SOA, because that was exactly what it was. So logic components as close to the domain systems, facilitating for transformations, etc., sending it to a message broker, facilitating the communication, and then to another micro integration or ESB component. So to some extent, it mimics the same behavior. So that's why I'm always laughing that you guys are recreating a service-oriented architecture with that.
Did you get a decent answer out of Andrew when you posed him to that on my office hours when I had him last month? Or do you want to dig into that a bit more, because he's the PM for micro integrations at Solus? So
we can dig into.
I can connect you with him. You guys can have a chat.
I already have him on LinkedIn. Don't worry about that.
All right.
But yeah,
guys,
we can have a chat of that.
Are we gonna get back to like Kafka and stuff? Because I want to.
Yeah. Well, I was gonna I had a segue on that, because.
Oh yeah, go on. Here, let's go.
Well, the one thing that's really nice about Kafka is that there's zero chance of accidentally putting business logic into the broker.
That's true. Well, it's literally zero chance of putting business logic into any message broker, because most of them cannot handle business logic, cannot implement business logic, which is that great thing. But that means that that's
in the layer above, that's the iPaaS, right? So.
Yeah, well, if you do event-driven in an integration platform, yes. But if you do communication through a message broker, whether it's Kafka, Solus, ActiveMQ, RabbitMQ, Artemis, whatever, then all that logic, it needs to be in the domain systems, which means that there's a lot more responsibility on the domain systems in terms of ownership and abstraction and contracts, and actually agreeing with other people on the scope, because that is done the hard part. If you put in abstraction layers above a message broker, like an integration broker or an enterprise service bus, then that responsibility then becomes the responsibility of the integration team or the integration architect that will go to different teams and negotiate for those teams. So becomes the negotiator, mediator between all the domain systems, which makes it a completely different workload. Again, to those who think that you could avoid working with people, there you go. You can't.
And can I just pull you up on one aspect of that? You said it becomes the responsibility of this person. I think we should frame it as it should become the responsibility of this person, because in many organizations it doesn't become anyone's responsibility, and that's where it all falls down. And so I don't think we should give people the idea that it will sort of magically suddenly someone will start taking responsibility for them. Like, you have to be intentional about this. You have to allocate responsibility, or someone needs to, an architect or a senior engineering leader or a CTO or whatever kind of it is in the organization needs to be making sure that someone has responsibility. And I think this is where it often falls down, is like the people that recognize that someone needs responsibility often don't have the authority to allocate that responsibility. And so it just sort of slips into the cracks.
And even rarer, somebody actually takes accountability and responsibility on their own.
Or they volunteer,
so that's a very rare sight. That's 1 in a million. But going back to Kafka now. Okay, we have Kafka, we have message brokers. Like we can distinguish saying, log broker and operational broker.
I want to like, how can we talk about Kafka without talking about topics and how they're different than your typical message broker topics? That's what I want to dig into. Like, we think about NATs, or you think about MQTT. It's a protocol.
I mean, this does dig into the difference of a log broker versus operational broker.
Well,
so basically,
it digs into what do you call a topic, right? And I have a video on this. It's like in Kafka world, a topic is a log file. It could be partitioned. There could be multiple log files, but it's a group and it's a stream of data. Whereas in my world and in MQTT, and I'm pretty sure in NATs as well, it is metadata on the message, right? Each individual message it's just a metadata. That topic is not an object in the broker, right? You have subscriptions, you have queues to attract that data based on that topic, and that matching happens within the broker. But topics do not exist as an object. JNDI,
that's a view that's based on like a white box or a transparent box perspective of your system. Like, it's how you think about the internal implementation of it. But a lot of brokers, the topic is considered like a concept or an entity. Like, if you look at RabbitMQ, the exchange is a thing you have to create. It's a key, but you create an exchange. And SQS or SNS, you create a topic. You register the presence of this topic, and you can attach configuration to it. So from the user's perspective, it looks like an entity in the thing. But I understand, like, internally it might not be implemented in that way. Like, but it does often, the abstraction looks like that from the outside.
Well, to be completely fair, looking, for example, at SMF versus JMS, both of these protocols, they have topics.
JMS is not a protocol, man. We've done this before. It's an API. It is every EMS, MQ, Solace on the wire. It's not a protocol spec. It's an application programming interface, right? It's a standardized way of making your app easy to port.
Either way,
you need a different jar.
In JMS-based message brokers, you had topics and queues, and like in Solace, you could define a topic that is dynamic or static. In JMS allowed you to do dynamic topics. And same in Solace. In Solace, this is more of a default to have dynamic topics, whereas in JMS the default was to have static topics defined and having ACLs assigned
as an object. As an object. In JMS, it's a bit different. Yeah, agreed.
So it really depends on which protocol we're using and which broker we're using. So basically, you could treat the topic as an object, but it's on the contrast to Kafka, a topic is actually in Kafka is a log, is a structure that holds data. A topic is just a means of transmitting data, which usually is as stateless as possible. I cannot say it's stateless because there are durables on topics, so in JMS at least. So you could have state on a topic, whereas, for example, in SMF on a topic you don't really have that state unless you're doing backwards compatibility to JMS. But you have the state on queues, which is also in JMS. This is how you should implement that as well.
Let me make a distinction just to kind of make it clear what I'm kind of talking about, right? If I'm a publisher, I'm going to publish on a topic that says Acme/orders/trade. That's my topic, right? It's a multi-level descriptor of the data that's contained within the payload. As a subscriber, I might want to listen to everything coming out of Acme Bank, right? So it's like Acme / greater than or plus
Star.
in MQTT. Or, sorry, hash is the multi-level wildcard. Or I only want topics, the orders data, right? So I could put star orders. So that is a subscription, right? That's a topic subscription. It's not the topic itself is ephemeral attached to the message. And inside the broker, it does not have a view of, unless it's tracking them, it doesn't have a view of the topics. They're just coming in as message metadata. The subscriptions it definitely knows about. That's how the subscribers request, their what part of that stream of data. I can be very specific, or I can be very granular, or very broad with wildcards. And so that's the world that I come from. That's how we think of topics.
That's interesting, because that sort of, I think, is connected to the legacy of Solus as a content-based routing system.
Oh, it's more RV. It's more RV. They had dot level separators, and you could
but thinking of it in that way, it's like the topic is just a piece of content that you can route on, right? So the way I think about what you're talking about a little bit is like functionally within a broker, you got two main responsibilities. One is like the message routing, like deciding who should receive the message, and the other is message storage for however long you're going to store it. Whether
totally
it's
decoupled in Solus,
Well, in Solus they're decoupled. In most queue-based brokers they're decoupled, but in Kafka they're not decoupled.
Kafka they're not.
That's one and the same.
Exactly.
That's the thing. That's the way I explain it to people. Is
addressing and storage should be.
Yeah. Well, it should whatever.
There are benefits
to it. But I think
this
is the way I explain it to people. And so this is how I explain to them, like the way Kafka is. You got to think about the routing and the storage are one and the same, which is because of their philosophy of putting the responsibility onto the clients. So the client does its own routing by either selecting which topic it's going to write to or selecting which topic it's going to read from. The broker itself doesn't actually do any message routing. It stores the messages, and it gives you a structure that allows you to make some limited routing decisions as a client, as a producer and a consumer. But it doesn't give you the kind of like flexible routing that a queue-based system would do, whether it's content-based routing or wildcard topic routing. SNS, for example, in Amazon SNS doesn't necessarily support that kind of. Like you have to register the topic, you publish the message to the topic, you can register subscriptions to that topic, but the topic is just like
very basic,
an opaque name. It's pretty basic, but it works for a lot of situations. I actually think that the support for wildcard routing is a little bit of a rope with which a lot of organizations hang themselves. Like I think that it sort of overcomplicates. Like you should maybe rethink your design. Why do you need to have that? Like. Because I'm always looking for like less data transmission, less data sharing is more loosely coupled. So let's try and find ways to like limit it. And I know, like, actually Carol and I have talked about this before, is like often coming up from a context where you're using domain-driven design to build and design a system. So you have got a little bit of control over where you allocate responsibility and what system elements are going to exist. And I think that a lot of these things that you're talking about are in a different context, very helpful, which is where you don't necessarily have that. The components already exist and you're trying to connect them up, or there's some of the components exist and you're building a new one. And so you kind of have to work with what's already there. And then having that flexibility is actually necessary. You need it. But if you have the opportunity to design the system, it's in terms of like architecturally choose what the components are and how they're going to communicate. It's very easy to actually design a system that doesn't need wildcard routing. And doesn't need that kind of stuff, because you can just say this is how they're going to work, and you can put that constraint in from the start, so you never grow to the point of needing it. But if you're coming along and later trying to add this onto an existing system, you absolutely do need it. And I think that context is important to sort of disambiguate between, because some people are in different worlds.
It's a difference between topics being a routing object and them being event descriptions. And so that's kind of like, if I'm a publisher of data, my topic is a multi-level descriptor of what's in the payload, and I'm exposing to that topic layer what are the pieces of me as my payload, could be 50 key value strings. What might someone want to route on and receive that data? And I might be interested in everything from Canada, country code could be part of there. You could get around to Dave and sovereignty. I'm only interested in stuff coming from finance, so I'm going to subscribe to finance instead of star. I'll put a star where I don't care what it is, and I very, very descriptive where I do. So, as topics as an event descriptor is I believe it's a much more compelling and complicated way of building your data distribution layer. So.
So it's all correct. It really depends on the use case and the scope. Because
Sure.
if you're designing a event-driven microservice system, yeah, you want that dynamic routing, that descriptor in the topic taxonomy to actually dynamically filter by the topic name and wildcards and whatnot. If you're designing communication and interaction system to system on that ecosystem scale, most of the times you want it very, very explicit and rigid, so that you have very rigid control over how that interaction happens and where that data lands, so that you don't have data breaches, so that you have observability, auditability over the flow of data, keeping that data lineage intact. So that means that if I am using a message broker within an integration platform, I want it defined very explicitly and rigidly without using wildcards to that extent, right? There will be some use cases where I would be using wildcards, but these are very small, narrow, niche cases where this would be actually applicable. Versus when I would be designing a microservice system, I would definitely be using a lot of wildcards and having that flexibility instead of having this very explicitly.
That's really interesting, Carl, because I wouldn't
think the other
do
way.
that personally. Yeah.
Oh, okay.
I mean, I wouldn't comment on the integration thing because that's not really my area of expertise. But in microservices system, I would generally try and make it harder for teams to be accidentally subscribed to data that they may not need.
I would be explicit
I would
in a
say only subscribe to the stuff you definitely need, and don't use wildcards. Don't accidentally oversubscribe, because when you oversubscribe, you are coupling to stuff. But that's the risk of wildcards, right? Because another event might come along later that matches your wildcard, and suddenly you're going to start getting it, and you don't necessarily know what to do with it, or you don't need it.
In async API, you're supposed to, like, you specify that, for this particular topic, which can include wildcarded components, that, again, could be a publisher ID. Just as a very simple example, that's the wildcard. It's still a contract, right? So if you're going to publish on this topic that's like Acme Bank orders /star, this is the payload. So, I mean, it allows you to add new publishers on new different publisher IDs without changing any kind of existing wiring in the broker. And the subscriber who's already wildcarded will automatically just start getting that data. So there are flexibility benefits, but it does require management. Like, you can't just have everybody publishing on a particular topic with any payload that they want. That's going to blow things up in 2 seconds. So,
I mean, to be fair, I would be using probably a lot more wildcards, but that's still the need for proper contract management still applies. It's like unavoidable. So this will still be more explicitly designed, but I would probably utilize more flexibility. But then again, I do not design microservice systems, maybe for a reason. I design interactions between domain systems, and I made a living out of that. And this always needs to be very explicitly designed because of regulatory needs, because of auditability, because of audit proof that is needed, because of logging, and all those interactions will, and zero trust on top of that. If we make those interactions very explicit, that very much complies with zero trust. That means that I can isolate a breach system really easily. So then wildcards are not exactly a thing that I want to have in such an environment, which makes it that I need to explicitly define routing. I need to explicitly define which content goes where and why and when, which makes the contracts a lot more rigid in that sense. It gives me more flexibility in terms of protocols and how those systems interact with the integration platform, and then I implement that internally. Would I be able to use Kafka in that regards in an integration platform? Probably no. Probably that would be a very problematic thing to do, because I need that routing capability. So any operational message broker is going to be a lot better. But given that, for example, looking at synchronous communication with micro gateways, I believe that's the product in Solus, right? Translating that to a pattern,
not often
pattern.
talked about, but yeah,
not often talked about. I know. A wiretap pattern from the enterprise integration patterns by Gregor Hopp and Bobby Wolf. A wiretap would go, for example, straight to Kafka, because a wiretap could be used for analytical purposes. A wiretap could be used for security analysis of spotting anomalies. And this is data that could be perfectly persisted Kafka partition for analysis, to store and replay for whatever analysis the whatever team is running. But this is operational data that needs to flow without that persistence. And then on top of that, I can make a copy to Kafka to keep that persistence, to keep the sequence of those events and what happened, so that this can be later analyzed for whatever purposes of analyzing the traffic, operational traffic in an ecosystem.
The other really big thing about Kafka topics is that by definition they're very coarse grained, right? They're basically a big funnel of all the data regarding orders, or all the data regarding.
Well, I mean, it depends on how you design it. That's
sure, you can have thousands of log files, and then now if I want to listen to all the data across all those servers, I have to connect to like 1,000 different topics. It's like the more fine grained you want to be in Kafka, the more physical sockets or files you have to have on their system. And so if you have a very coarse grained topic, if I need to do filtering, I now need to use K-streams or K-SQL or something to kind of go in, pull everything out, write it to a new place.
Filter it. Yeah.
Which is a lot of, that's in client space, and it's a lot of extra work, and you're double reading all the data versus having a million different log files, and Kafka doesn't really work that great. If I want to listen to everything now, I have to connect to a million different, topics. So again, another strong reason why, wildcards versus not wildcards on a multi-level topic string.
But it comes back to like your design philosophy in the system. And, I think, in the world I live in, all of the systems I try and design, coming from a domain-driven design perspective, you try and think about modeling your events as being based on some fact about the business domain, and then you reflect those events as topics. And as subscribers, you subscribe to the events you're interested in based on your event storm or your event model. So the scenario where you need to subscribe to like everything to do with orders is reduced, like, because you kind of say, well, I'm only going to subscribe to the domain events that I'm interested in, not everything to do with orders. And I don't actually want to allow or want to make it easy for a new logical publisher to come along and start publishing that same topic, because if the topic or if the events represent domain events, then there should be one single authority on when that domain event has occurred, and that is the logical service that is the publisher of that domain event. So if you are adopting that domain-driven design philosophy, you kind of don't need to worry about some of those things, because you kind of constrain it from the start to say, we're just not going to do that. We're just going to say we have events reflect domain events, subscribers subscribe to domain events, and they subscribe to that specific domain event or the one that they're interested in, and you kind of don't let them sort of subscribe to everything to do with a given like namespace, because that's kind of, you just don't need to. Like, why would you? You've designed the system, you've done the event storm, you've modeled out the business flow, and you've designed the different parts of the system. But I definitely see like there's environments I've seen where that's like, you don't have that possibility. Like you've got components that already exist, or you are sort of focusing on it as like, either integration or message flow, like data transmission, and you're not thinking about it as like we're designing the microservices system or the SOA system or whatever to be modeled around different parts of a domain, and we have the opportunity to consider the whole system at one time and to make those choices at the same time. But if you do have that, you don't need some of those capabilities. But I think the interesting thing about getting back to Kafka and the disambiguation between topics and storage, because I have had people come and say, well, how do you think about things like AWS Event Bridge? And it's like, oh, well, that's, now I can explain this, like that does the routing, but not the storage. And MQTT is kind of similar. It's like focuses on routing and not necessarily storage, although there's,
QoS1,
some limited scenarios where it can do a very simple or small amount of storage. And then Kafka is like, it is just the routing and the storage is baked into one thing. And then there is a consequence of that does play out in like domain-driven systems, which is that not every message is an event. Some messages should be modeled as commands, and a command logically should flow from multiple senders or multiple
or request replied.
Or a request was reply, but if you need to do that. And Kafka can do that, but it's not oriented around it because its topics and storage are baked in. Whereas in a queuing system, you can just bypass the topic layer and go straight to the queue that is owned by the responsible party for that command, and that keeps your like logical topology aligned with the general intention of events versus commands. And actually, I've seen a piece of Confluent documentation that says, oh well, you want only one service to sort of be responsible for this thing, and multiple services are going to be sort of initiating this action within that responsible party. So what you need to do is you need to put a command event on the topic. And I'm like, what the fuck is a command event? Like, that doesn't make any sense to me. These are different, like actually opposing ideas. And it kind of reveals the fact that it's like, because the concept of the topic and the storage are baked in, everything becomes an event. And then even the word event loses its meaning, and they just start to use the word event and message interchangeably. But then when they do want to describe the meaning of a command, they go command event, because what they're really saying is a command message, but they've forgotten that the word
1000%
has meaning. And that's an interesting side effect of that design decision, which comes from, as you were describing, like, it's a distributed log. They were just taking logs from all the web servers and then processing it, and then realized that these kind of log messages could be used to represent events, and then started to be used for this purpose. But it was never the original design intention of the whole structure.
Kafka, they're actually called records. Like, if you look in the API, like
at the base,
they publish records.
Absolutely.
But
like you got record list or record array. Totally.
In my opinion, like it's marketing events. Events is sexy and cool and EDA and whatnot, and it's not. Messages is old, so that's why everything's an event, but it's not. It's it's different types of messages. An event, a business event, goes in a message as transport, but they've been
an entity can live in a database record, but a database record, not all database.
They've been conflated. These terms have been conflated, and it's just command message.
It's so annoying. It's so annoying. Why can't everyone just use the same terminology as me all the time?
Oh, it's the same problem, right?
Sure.
I don't know, Chris, if you recall the talk from Jackie Reed from DDD Europe. I don't recall this is
every event, everywhere, all at once. It's a beautiful title.
Exactly.
That's another good title. That's
title.
A great title. Yeah.
So basically, Jackie differentiates between command, message, state, and event. So command, like create, start, complete, state, to do, in progress, done, event, created, started, completed, and then message. She was like, I like creating work items. I thought you started this already. These are they don't have that semantic of what is So basically, every event everywhere. That's a great talk. I'm just gonna
all at once.
Grab it.
And it's interesting. There's a couple of talks out there that kind of try and disambiguate events. And there's one by, I'm trying to remember the title of it. It's a few years old now. Martin Kleppmann, who's one of the creators of Kafka, who tried to do a talk disambiguating events and the different types of events there are. And I watched this talk, and he listed like 30 different types of events, and not a single one of them was the types of events I've been dealing with in the systems I work with.
Oh, wow.
It just sort of highlights like how diffuse this kind of like landscape is, and how confusing it is to someone entering it and just hearing
terminology bubbles everywhere.
They feel like they know what's being discussed, and actually
people as technical people, we really suck at naming things and keeping cohesion of a language.
I think cohesion is interesting because it's impossible really to have cohesion. But what I think we should get better at is being explicit about context. Because it's fine to have different, so the same term have multiple meanings. And we actually, like, as humans, we're very implicitly context aware, and we can usually disambiguate, depending on the context in which we're having a conversation. But a lot of these, a lot of text around this is contextless. You're reading it on a blog or or something, and you're missing the context. And this comes back to the cargo cult thing, because a lot of the problem is lack of context and understanding like how to understand it within a given context. And so I'm a big advocate for being really explicit about context, and that's why I keep coming back to, well, in my context, which is designing DDD systems, where I've got this responsibility for choosing these different components or designing allocating responsibility to different components. You make different design decisions, or you can choose to use these tools in different ways. And in other contexts where you are integrating between pre-existing systems, but that's just one framing of context. There's many other contexts around, and the word event, sure, it can have 50 different meanings, because there are literally 50 different contexts within which it has a useful meaning. And so we just need to, I think, get better at like being explicit about context.
Yeah, and establishing context and establishing a shared dictionary for a context is one of the most difficult parts of the job, basically. I just recalled in my brain the discussions I had with Philip when we were discussing materials over event-driven architecture. I was like, okay, there is this thing that is called anemic events. And it was like, what do you mean, CRUD? I'm like, no,
Thin
this
events.
is this event thin event where you send just the identifier of the record
Like an
that
ID.
changed.
Yeah.
That's not an anemic event. That's a thin event. I was like,
Anem-
that's called an anemic event. Yeah, in EDA or in technical jargon, that's called an anemic event. In DDD, that is not an anemic event. That is something completely
Well,
else.
because in DDD, they use the phrase anemic domain model, which isn't thin. Like, it can have a lot of data, but it doesn't have any business logic. So
Exactly.
an anemic domain model, it might have 50 fields, but no rules.
And an
so we
anemic
say,
event
like,
is
there's
just
no
CRUD.
I've never heard of an
event,
anemic event. I know thin versus thick, right? Like fully cancer, fully.
But it's funny, right? It's a metaphor, right? We're lifting it from the medical context, where anemic means like lacking iron. Like we're not getting enough steak in our diet or enough mushrooms or whatever. But what it's like metaphorically, it's being used for like you're missing substance, you're missing like meaning or like something valuable, and it's appropriate in all those different contexts. But it does have like subtly different specific meanings.
It has. So we had the whole conversation while we were just establishing in which context are we, because we're designing a course material, how to use DDD with integration architecture, and so we're suddenly having two terms clashing because they are both valid terms in the context of this course that we're designing. They both should be in this context, but they're the same term meaning completely different things in one context of one course, but the course actually attaches technical concepts and DDD concepts. So now we need to like be very explicit in which context we are at the moment to actually talk about that. On that note of two types of event, Aaron, there's a third one.
Sure,
of course. Delta.
A delta. Oh yeah. And okay.
So you have a thick event, which is the whole payload. A thin event, anemic event, which is just a notification of this record has changed.
I've heard it called like an initial, like a fully initialized map with all the keys, and then everything else through that is delta. Yeah, we see that in trading platforms all the time, right? You're only sending the buy sell top tick. You're not sending the full book or data.
And this brings.
And then you have to do merges, right? Delta merges, and
this brings it to a lot of problems, because then if you're using operational brokers, not every operational brokers handle FIFO well. If you're doing delta events and pushing deltas of payloads, then you need to have FIFO, or you need to distinguish that somewhere in the consuming system that this is out of order. So you need to actually have some sort of a sequence key or something like that would tell you that what the order is. And if you spot out of order, you hold processing until the order is complete, or you handle this in the message broker. Whereas in Kafka, FIFO is out of the box, basically baked into the partition.
Well, it is, but as is often the case with very limited granularity, by partition, not by topic, and not by any kind of domain meaningful key, unless you create a shit ton of like partitions. So and that's what I really like. There's a bunch of queuing, like Amazon SQS handles it quite well with like group IDs or whatever, and you can make that whatever you want. So you can make it your entity ID, which means you get FIFO within the scope of messages or events relating to a single entity instance. But you don't necessarily have like FIFO blocking across the whole topic or the whole queue. Whereas with Kafka, right, like FIFO is guaranteed out of the box. Great, wonderful, we got FIFO. But when you realize the limitations of the granularity there, it's by partition and not by anything sort of more meaningful. It's actually less useful than you first imagine.
To be honest, from a perspective of designing interactions between domain systems, I mean, within a system, probably more common, but between domain systems, I may be one valid use case to use FIFO. That there was, I mean, other use cases that somebody imposed FIFO was like, but we can do it a lot simpler. Why are we overcomplicating ourselves now with baking FIFO into it? That all the systems need to take care of that FIFO, so that actually is a FIFO, so that this system needs to publish in a correct order. They need to keep to that. Now we need to hold that state somewhere with the order. We need to hold processing if something falls out of order by any error means. That's a complication. do we really need FIFO here? And literally in my career of 15 years, I saw one use case where they actually needed FIFO, that this couldn't be simplified. So it's like it all comes down to
I totally
purpose
agree.
and intent, and we tend to overcomplicate things just for the sake of overcomplicating these things. As Barry would put it,
big fan
love
of
complexity.
Totally. I'm a big fan of pushing teams to abandon FIFO if they can. Like a lot of them assume that they need it out of like a design, like it's the first thing that occurs to them. It appears to be the simplest solution, but it often isn't. And it often obscures very valuable domain insight that could be there if you were to sort of embrace the eventual consistency or the, potential for out-of-order processing, because real domains are not FIFO, because real domains are based out of like lots of people working in parallel doing lots of different things. And if you try and model that as FIFO, you're basically creating a sequencing constraint that's artificial from the perspective of the domain concept itself. And so, this often gets sort of revealed through the perception of race conditions and trying to avoid race conditions. Like, oh, we can't let them cancel the order after, they've placed it or after it's shipped or something. And so, well, what would happen if we have an order placed and an order cancelled? Yeah. And so people go, oh, well, we can't let, so we're going to block it at the UI, but then maybe the UI is stale because it's eventually consistent. So what happens if an order cancelled event ends up being handled after the order placed event? What's the downstream system going to do? And we can't allow this, so we need some sort of time sequencing. We need FIFO, and we're blocking it as a technical mechanism. And then when you actually go and talk to the domain experts, they're like, well, of course we would allow cancellation after shipping, and well, then we'll have a process where there's a returns process, or there's a refunds process, or there's a business policy that handles that situation, because it's a thing that really happens. So you actually need to account for it. And if you try and solve it with like a technical constraint, you're actually like denying yourself the opportunity to understand the domain more deeply.
But what about the other way around? I mean, like a system, I try to buy some stock and then I cancel my purchase for that stock immediately, right? And somehow the cancel arrives before the buy. I mean, like that certainly would screw a lot of systems up. They would get a cancel order for a trade that doesn't exist, and then they would go off and purchase something after, unless they persisted that cancel state, saying maybe this is wrong, and So I
mean, that's true in that domain, and there are domains where that is a real thing. But there are ways to handle as well on the consumer side. Like in the pattern that's often applied there is what's called the saga pattern, where you do you do hold that state. You go, well, I've just received a cancel thing for an order that I don't recognize, so I'm going to hold on to it for like an hour or two, just in case the order comes in. And then when the order comes in, I know it was already cancelled, so I can just deal with it. And that puts a bit more complexity, and puts a scenario or a use case that the consumer now has to handle that they otherwise wouldn't have had to handle.
We come from financial services, and so FIFO is nice to have. Like that's just, it makes things easy, I guess. But to your point, you're right. The real world doesn't operate in a strictly designed like global ordering. So like being able to have eventual consistency, moving away from transactional data, if you can be out of order and be tolerant to that, that is very useful, because that means you can horizontally scale however you want with round robin designs and all that things. It's just,
and so that's a technical reason for it, and there's also domain reasons for it, which is that it usually, not always, but usually leads to a better like model of the domain, like a little more realistic model of the domain. Udi Dahan, who's the guy who created in Service Bus, has a fantastic blog post about this called "Race Conditions Don't Exist," and he's kind of like, he's trying to say, a lot of technical people assume that race can. That's awesome.
Hey, dog.
He got fed up with me talking and time for walking. Yes, he's basically asking, let's go on a walk. It's my time for an evening walk.
I got stuff to do, man.
He's like,
so
I got a walk timeout error exception, or walk timeout error over here.
That's an event. Yeah, the event just came to me. Yes, that happened on several streams already. That he just jumped on my lap and he was like,
2 hours and 5 minutes. That's a cutoff. So.
That's for him. It's a
Chris. What's the name of that talk again? There are no race conditions.
It's a blog post. The race conditions don't exist.
Race conditions,
and so it's mostly I mean, it's a pretty short one, and I think it warrants more digging into. But I've seen him talk about it as well, and I can't remember where. But I think it's very important, like people doing domain modeling, to realize that race conditions tend to not exist in domains. And you talk about financial services, obviously stock trading is one thing, but like, a lot of people think about transactional consistency versus eventual consistency, and they get and the classical example that gets brought up is a bank account transaction where like money moves out of one account into another, and everyone uses this as like, well, that must be in one transaction. Obviously, I'm like, have you ever seen a bank? Like, that's actually not at all how banks work, and certainly not interbank transfers. They're eventually consistent because they can't have a distributed transaction across two different banks. So, actually bank account transfers are a canonical in real world implementation of eventual consistency. And banks have like accounting processes to deal with the fact that money is in transfer, or, and they have end of day processes and end of month processes to kind of let things settle down before they run their stuff. But they definitely don't impose like transactional consistency across that. And even though that's like the, transactions 101 example that is often given to people learning about database transactions. And I think that there's many other domains where that's the case, like booking hotels. Everyone's like, oh, we can't overbook the hotel. And then you go to talk to hotels and like, of course we can overbook the hotel because we're going to have cancellations. We're going to have no-shows. We can't overbook an airline. It's like, well, I would prefer it if you didn't overbook the airline, but they definitely do allow overbooking of the airline. And so once they allow overbooking, you don't actually need transactional consistency on the bookings of the flight, because you're going to allow an overflow of an overbooking and oversubscription, because it's actually better business practice to do that, because then you're not denying yourself to follow when you have the inevitable cancellations that are going to come. So when you talk to business experts, they usually have a far looser concern around transactional consistency than technical people do, which actually leans into EDA as a practice, because EDA naturally sort of models that, and it flows quite naturally.
Exactly. So you mentioned that blog post that's race conditions don't exist. Is that by Udi Dahan? All right. Just to plop that in as well, because that's I believe that's going to be a piece of a valuable.
It's quite old. Like, he wrote it like over 15 years ago or something. He's been talking about this topic for ages. Like, he created in Service Bus.
16. That's 31st of August 2010. So quite an old one already.
There you go.
So it begins with "not in a business world anyway." So that's exactly what we were talking about. and
Carol, before
we've been at it for
All right, go ahead. No, finish your thought. Sorry.
No, before, because I was already aiming at wrapping. So
I was just going to say before we wrap, are you going to share that EDA Summit talk from our CTO, talking about operational versus analytical brokers and how they each serve their own purpose, and the Venn diagram of their overlap is there, but scan this.
So basically, for this is exactly the point of the wrap up. So basically, there is a difference between log brokers and operational brokers, and the difference is significant in terms of
queue-based brokers. I would say log-based brokers versus like queuing or topic routing.
Queuing, operational. I call them operational, but this is exactly what this distinction was made by Sean McAllister in the EDA Summit talk. So the case is, well, if we focus on the technical side and use them as tools, that we're going to miss probably quite a lot. The tool needs to be fit for purpose, like in anything we do as IT professionals. Our development, our software, it needs to be fit to whatever is the problem domain that we're solving. If we don't have a proper understanding of a problem domain, we'll most likely end up overcomplicating our lives with tools that are not fit for purpose. So while we can all say that we can do EDA with Kafka, is that the best choice for EDA? I will argue probably not. Is that the best choice?
Asterisk, depending on your definition of EDA.
Full circle. We're full circle.
Full circle. But if you're looking at events as they occur in business, then Kafka will definitely not be the good choice for that, to be very operational, stateless, and fast and whatnot. It's going to be extremely fast, but not for that purpose. If you're doing something that is analytical and you need replayability, you need partitions that store that data, Kafka is going to be perfect for analysis of data that you run over and over again for different purposes. Perfect, right? So it really depends on fitting the tool for the right job that you're actually designing for, which means that sometimes you'll need Kafka, sometimes you'll need a different broker to handle these things. And depending on what you're doing, sometimes Solus will be great, sometimes Solus will be absolutely bad for the use case that you're handling. while it's being a very well-rounded broker. And same with typical EMS that was one of the best implementations of JMS. It was a good implementation of JMS, but JMS fell out of fashion because we have now different protocols that maybe fit better, etc., etc. So it really depends on. It's still around, definitely. We have plenty of legacy systems in financial world that still rely on even rendezvous at times. So this is it really depends where we are at, and sometimes they just don't want to rewrite that, so they just want to backwards compatibility.
Devs are lazy.
Before we go, there's John posed a question. Just like the main models, schema ownership, you'd need some sort of ownership for sagas as well. But they tend to be rather language project bound and difficult to share. It's more of a collaborative graph rather than an interface schema. Yeah,
it can be. My preference is to make a saga the responsibility of a single logical service, like a single bounded context. They own the saga within their sphere of responsibility. If you're thinking about a saga as something that is a collaborative thing, then to me, I'd model that as like separate sagas, like each service has their own saga, and then you've got a business workflow that is choreographed between them. Because I think you need a saga is something that has state associated with it, and so there needs to be an owner of that state. And so I think it's just a lot simpler if you just make that responsibility of a single bounded context. But I don't know if that really speaks to sort of John's point there. It's hard to have a dialogue around that.
It puts a emphasis on ownership because we tend to think about the ownership of a bounded context. So whatever is the implementation of the bounded context, it kind of makes it to some extent easier to own and manage. Yeah. But yeah, I think that's a fair. To
me, it's a private implementation detail of a service. Like other services shouldn't be aware that a given service is using a saga internally. That's like a private detail.
And given the number of different sagas and their different qualities, that should be private to a very much extent, because that's otherwise it's going to be a very intense coupling going on between internal services.
Yeah. Hey, since you're sharing links and things, I just remembered there's another talk I want to give a shout out to, which is Ian Cooper has a talk called Polyglot Flow. And I really like that title too, because he's using polyglot from the way that people are thinking about like polyglot languages and systems where you go, we're going to use Rust for this because it's the right tool for the job, and we're going to use like Node.js for this because it's the right tool for that job, and C# for that, or whatever. And he's saying like polyglot flow is a concept of saying we need to use the right tool for the job, and most businesses, in his view, probably need both. And they need like a distributed log type system, streaming system, and they need a queuing system, and they should use the right one for the job.
10.
And I think one thing we don't need 10. You probably only need the 2. But what I think something we didn't actually really get a chance to talk about on this is how often organizations, once they have one, that becomes the default for anything related that even smells or looks like messaging, and it doesn't.
I've seen app teams like everybody picks their own. I have some customers that have 9 different broker technologies within the bank.
There you go.
And like the CTO is like, it's insane. Like we should have 3 or 4 max, and it's just like, these teams picks Rabbit, and these guys, and how are you gonna do like enterprise-wide integration if everybody's speaking? I don't know. Anyway, so. I don't have time to get into that now, but we can. But
it's the same aspect with integration architecture. People tend to stick to one type. So basically, if they already invested into an ESB and they're doing API-led architecture, the derivative of SOA, they're like, we're going to push everything through that. Even if it doesn't make sense, even if it is just like the granularity of MQTT, you shouldn't be using an ESB for anything related to IoT, right? Sure. MQTT would be the perfect thing. So that's event-driven architecture with a very fine granularity. No, we're going to push it through an ESB.
Well,
and like sitting there, why?
That's because that's what right? I mean, like my example was each team is picking their own thing randomly, right? So or based on their particular requirements. But like if you are building a second tool, I'm going to be like, I already know this tool. I'm going to use the same technology. So
It is
Pretty much.
interesting because, like, because especially with the microservices movement, there was this big push for teams to be empowered to choose their own technologies, and I think people sort of forgot that, like, okay, that's fine for the private decisions that you own, like your database and your tech stack and your language, but it
Your
shouldn't
language.
be the case for like things that are
Middleware.
about the interaction between teams that
Oh,
need
yeah.
some sort of governance and like separate ownership, and messaging middleware is exactly
Or,
that.
or even protocols, right? I mean, like you could have REST, GRP, like you could have maybe less so, but yeah, any like operationally, I would say an ops team that has to manage 5 different database types rather than just 1 or 2, they're probably not as happy about that.
I'll give you one better. API management.
Mm.
It's like every
live stream,
system
Carl.
has its
That's a
own
whole nother-
API management, to the extent that people started thinking about federated API management. So they build a tool to federate to all the API management tools that are used in the company, because you have 10 API management different solutions. So now you have one federated API management that connects to all 10 of them and starts managing all 10 of them. It's like that's a horror story, basically. But these things happen a lot in organizations, especially if teams are given too much freedom on the extent of what tools they choose for the job, and they're not directed into like, okay, we have too much sprawl, so
well, now you have 11
stop.
API management systems. So
now you have 11, yes, because we're again solving the problem that is an organizational problem with throwing a tool at it. There we go. And with that note, I think we can go to closing. So before we go away, now we're going to have the next live stream in about 2 weeks from now. Pretty much 2 weeks. And this is going to be completely different than anything else that we've done on Loosely Coupled so far, because we're actually going to do live coding. And we had James Herr approaching us and saying, hey, can we do a session with to show off what is ensemble programming? And I was like, okay, we need to figure out what is a use case for that. We need to figure out how to deal with that. So we've actually found a use case, and we're going to be having ensemble live in 2 weeks, and we're going to be building a very specific tool that is actually missing in the integration space. So hopefully that will result in something fun. And of course, as always, if you manage to survive with us to this hour, after 2 hours 20 minutes, that's a lot. Of course, QR code to the left, any upcoming events at Bridging the Gap involving loosely coupled talks, etc. In the middle, strategic integration design. Oh, I didn't change the QR code to Avant Scoperta, but DDD Academy also hosts the course. And of course, please subscribe to the YouTube channel to get notified about any upcoming loosely coupled live streams. Not necessary, but it's nice to see the numbers grow, but do what you want. Anyhow, gentlemen, it was a pleasure, a very unique pleasure, given that we're all in very different time zones.
Are you going back to bed, Chris, or are you going to stay up for the day?
Oh, definitely. No, it's 5:20 a.m. and my kids are going to be waking me up in a bit, but I'm going to try and get a little bit more sleep.
Quick cat nap there. Thanks for.
Or maybe I'll just
thanks for trucking through.
Fire up the PlayStation and punch out some gaming until they wake up. So.
Nice. All right.
That's also a nice way
Dad's
to do it.
Cool.
I mean, I'm gonna hit up Cyberpunk just in a moment. So after I walk the dog out, so nice. Gaming is gaming. But Chris, thank you for your sacrifice of your sleep to join us in the conversation. It was a really fun conversation to be had. So thank you for that, and thank you, Aaron, for joining as well. Sure. And for all of you still watching, because there are still people, I see in the numbers flipping on YouTube and LinkedIn, that there are still people watching. So thank you all for joining and tuning in and commenting on the stream. It was a pleasure.